Hello everybody and welcome to Microsoft Flight Simulator. We're sitting here on the ramp in Jacksonville, Florida with the fairly newly released Boeing 727-200 freighter from Flight Sim Studios, and it is a gorgeous airplane. This is such a fun airplane to fly, and I'm going to be doing a whole masterclass series on this aircraft. However, at the moment, since we're so close to release, I mean, it's already released, but we're so close to since it's been released, there haven't been any updates yet on it, and it needs some. There are a few bugs, specifically regarding how some of the systems operate. The aircraft is still totally flyable. Depending on what navigation source you use, there's some of the GPS stuff is having some issues with some of the autopilot stuff. We're not going to be using GPS in this flight today because it's more fun to fly it with the old school stuff, and that's how we're going to do it. So I thought I wanted to get a video out because I'm seeing a lot of people struggle with certain aspects of the plane. It is a complex aircraft because it requires 3 pilots normally, and we only have ourselves. So I'm going to show you, first of all, how you can use some of the automation to make your life easier. But in the video, I'm going to show you how I fly it without using any of the automation because I think that's more fun. So we've got a flight today. Actually, it's a long flight. It's the longest flight I've ever done in a 727. So we're gonna try it. You're not gonna have to sit through the whole thing. It's like a 5-hour flight. But we're going transcon basically. We're here in Jacksonville, Florida. I'm gonna take this thing all the way to Oakland, and we're gonna use the INS and radio navigation. Pretty much radio navigation, but we're gonna back it up with the INS. So I'm gonna show you what I mean by that and how we're gonna do that. But don't worry, we'll cut the video down, so we only have to be watching it for the important bits. But I wanted to get a video out, kind of showing you how you can fly this airplane, kind of a training video, so that way while we're waiting for the masterclass series, because I want to wait until the systems are working and fully functional. Which they are functional, but they don't like the pneumatic system. There's a lot of things that it does that it shouldn't do, and things like that, and they're tweaking those, they're fixing those. So there's a good list of bugs, but they're not showstoppers for this aircraft. Okay, so the first question is, should I wait to buy it? And I would say no, especially if you are not a what we call child of the magenta line. Go for it. This aircraft is so much fun. If you really need the GPS stuff and whatever, then you might maybe wait just a little bit, at least until the first update, because there are, like I say, some issues with the autopilot interfacing smoothly and consistently, I guess, with some of the GPS units. I think primarily with the paid one, the TDS, I want to say, or TDI, I can't remember. Whatever one of those ones is. We'll look at it in the manual in a second and we'll see. If you have that one, I think that one's giving people the most problems. If you just use the GNS 530, I think for the most part that one's working pretty flawlessly. But like I said, I don't use the GPSs, so I can't really speak to that. Because if I want to use GPS, then I'll just fly a magenta line plane. Like, I'm not going to fly this for that. There are also some instances of people recording where the aircraft boots up and some systems are borked and it requires a reset. And the best way to accomplish that, again, I don't know why that is. It has something to do with when the plane compiles on initial load. And I've only experienced that happening once to me, but I have experienced it, and I know a number of people have experienced it, and it's frustrating. I know, again, they're looking into that. They're trying to figure out what's causing it. It's sporadic. It's not constant. But if that happens, for instance, like the cargo door just won't open, or the speed bugs won't sync like they're supposed to, that's a good sign right in the beginning that there's a problem. Don't continue the flight. Just stop right there before you get yourself off the ground and have problems with the autopilot. Go to the escape menu, the active pause menu, whatever you want to call this, and hit this restart down here. And that will reload the aircraft without you having to go back to the main menu. It'll put you right back where you were. And 9 times out of 10, that solves it. So if that doesn't solve it, there might be bigger issues. But start there. Try that first. The other tip I'm going to give you before we get into the meat and potatoes of this thing is regarding the camera system. When you load into this aircraft, you'll find that the camera system feels very zoomed out. If you look around the cockpit, you'll kind of feel like you're almost on a fisheye lens. And I don't know why FSS decided to make that the default view. It feels weird to me, and I don't like it at all. So I initially zoomed it and saved my camera views, and then I went and compared the default camera CFG to other aircraft in the sim and found almost all the other aircraft had a very similar standard zoom level, and FSS had one that was way off the rails. So I'm going to show you, if you feel comfortable doing this, this is, you know, you're taking your own risk by messing with files. So I just want to put that right up front. But what you want to do is go into your community folder, wherever that lives for you. Mine is separate from the sim folder itself, and that's a whole nother topic of how to do that. So there's YouTube videos for that. But go to your community folder, and you're going to find your FSS aircraft Boeing 727-200F, and you're going to go into Sim Objects, Airplanes, that aircraft again, and you're going to scroll down to find the cameras.cfg file. It's just a notepad file. You can open it in Notepad. And you're going to look down here under camera definition.0 and let's see, where is it? Initial zoom right here. This by default is set to 0.95. Almost every other aircraft in the sim is set to 0.035, 32, 36, somewhere in that vicinity. I set it to 3.5 and I love it there. So if you want to make a copy of this file and save it somewhere just to make sure you remember what it goes back to if you want to fix it, but make sure the sim isn't running when you do this. Change it to 0.35, file save, you're done. And when you go back into the cockpit, it'll look like most other cockpits you're used to as far as the zoom level. So that's just a nice little trick there. I figure I'd help you out and get you set up with that. Okay, now that the asterisks are out of the way, per se, like I said, we're going to do a much more in-depth flight. This is going to be very surface level, but it's going to show you the flow that I've developed to work on this plane. I haven't refined it perfectly yet, and I may miss something and go back to it because I'm still learning my own flow. And I've got my own. It's adapted from TWA's individual flows, but those flows are for the captain, the first officer, and the flight engineer, and each one has their own flow. And it doesn't make sense to do each of those individually because there's only one of me. And it also doesn't make sense to do one of them and then go and do the other one because there's some overlap. And some of that's because the captain's double checking that this got done, even though the flight engineer already checked it. And so there's no point in redundancy of the same person because that doesn't prove anything. And that's what we have the checklist for. So we'll deal with that. But so it's my own custom flow that I think works fairly well. It's also a little different from TWA's because TWA's cockpit layout was slightly different. You'll find that almost every 727 that exists in the world had slightly different layouts where all the instruments could be in the aircraft and what instruments were included and what versions of those instruments. So there's not a one-size-fits-all here anyway. And even in TWA's own manual, it mentions 3 different aircraft styles that they had that could exist with just the FE's panel. So anyway, so that's why we've done that. So we're going to start here. I'm going to use GSX only for the stairs. We're not going to use it for the boarding. There's another issue there, and that is more with GSX in that it recognizes the 727 as a small or BBJ and therefore brings 1 pallet of cargo. I've already messaged on the forums to see what the issue is there and how we can fix that. There was an update from GSX that said they were supposed to fix that, but it hasn't fixed it on this plane. So I don't know what the issue is and how to fix it. Hopefully FS Dream Team takes care of that in short order and we can have more cargo bins come up so we have our immersion, as we like to refer to it. Okay, let's get on with it. First of all, let me just take you around the airplane. It is an absolutely gorgeous bird. Flight Sim Studios did an amazing job modeling this aircraft. I mean, the details on the tires are great. They've got these little I don't know what you call these things, but the kind of way the tires stick out here is designed to allow water to splash up and kind of out away from the aircraft, whereas normally you would let that splash kind of up and around the fuselage because you want to avoid the wing-mounted engines. Well, in this case, you don't want it to go over the wings right there because you go right into the engines in the back. So you actually want it to go out wide, and that's what those things are for. They've even modeled that. You've got the 2 air inlets for the air conditioning, the PAC system right here. The APU for this aircraft actually lives in the right near the gear bay inside the center here, and the exhaust port comes out the right wing, which is actually, this is realistic. That's actually where it happens. So the intake's in there, and then the exhaust in there. And because the intake's in here, the APU is not rated for flight because this gear door will be all closed up, and it's going to be trying to suck air out of here, and there's like very little airflow. So the APU is not rated for in flight. You've got 3 engines, so you should hopefully never be in a situation where you flamed out all 3. there you go. That was one of the reasons why tri-jets and quad jets existed in the first place, was engine reliability redundancy, because we didn't have engines that were rated to operate and could be operated reliably for so long, and only have 2 of them and risk getting down to none. So nowadays engine technology is much different, and that's why the tri-jets and the quad jets are disappearing, because it's more maintenance heavy to have more engines, and more things can break and more things you have to replace. So if you can only get away with 2, even better. The flaps and the slat systems are very well modeled in this aircraft. You've got the famous T-tail on the 727. The reversers do animate. They're the bucket style reversers. You'll see them come out sideways on this number 2 engine, and then vertically on the 1 and 3. I'm told that they are tweaking that and going to the Cascade style, where it's just a bunch of vanes up here, and the buckets are actually limited to inside only, which apparently for the JT8D-9s, which is what these are, was much more common. They did not have the buckets on many of these, and they got retrofitted out pretty quickly. So anyway, I kind of like the buckets better, but it is what it is. So I hear that's getting changed. As of right now, too, they only extend when the reversers go into full reverse, which is not correct, and that's something they'll fix too. But right now, you have to go into about 80% reverse before they animate. It's going into reverse, in the sim, but realistically, they wouldn't be, because there's nothing blocking the flow until they start to go. So. But it looks really good. The doors are operable from inside, so you can click those and open them up. Same thing with the cargo door, and we'll show you how to deal with that here in a second. And but it's just it's so beautiful. It's so nice to have a 727 in the sim. So kudos to FSS for doing that, and just looking forward to getting some of those bugs taken care of, because it's just going to make this thing even better. So, all right, let's go ahead and get on board and start the process of setting this aircraft up. All right, so I set a view here to just start kind of in the doorway. You can see the stairs there, like we just came on board the aircraft. And in this, we're actually, some aircraft, they just had a big net here, and you can see all the way down. In this one, it's all blocked off, but you can move this panel, and then you can duck down here and get into the cargo hold, and you actually see in here and move around. And the cargo, as of right now, is static. It doesn't adjust with the level of cargo on the aircraft, and doesn't change up. Eventually, I don't know if there's plans to make that. I know there's a number of people calling for it on the forums, to make that kind of change and be more variable with the amount of load, and empty if you have an empty plane. I think that would be very cool. But I don't know if that's the plan. There's even some horses back here, and I'm told they like whinny or neigh occasionally. I have yet to hear that, but they're there. The other thing, we have the DB Cooper stairs back here, and so like I said, you can open these doors in from the airplane. So this is an unpressurized area, by the way. That is a pressure door, and you can tell because it's got that door handle there. This lowers right here with this handle. It's not going to lower right now because I don't have any hydraulics on the plane. So, but you can just come back here, open that door, click that handle, and watch those things lower. Now there is a limit. You can't walk any further than that. I think is like I can do. Yeah, I can just go down. Just like kind of a lot of other airplanes where you can't get outside the model. So you can't just walk out here and down the stairs, at least as of right now. But here's the S duct you can see coming down toward number 2 engine, which is going to be, once it evens out there, it's on the end there is the engine. This is all just intake ducting for that number 2 engine. Let's go ahead and close that. Boom. There we go. So I'm going to go back and quick travel back here to my position where I was. There we go. All right, so I'm going to close this little... Actually, I'm going to leave that hatch open because I'm going to show you when we open that door once we get power in the aircraft. All right, so let's focus on getting this thing turned on. So what I do typically when I come into the aircraft is we start with the initial safety check that the engineer would do to make sure the aircraft can accept power without breaking something. So there's 4 things we want to check. That's the gear handle down, that's the flap handle is either up or agrees with the gauges and outside. Because what you don't want to do is have some system start moving under hydraulic power when you're not ready for it. If someone's nearby, that could very seriously injure somebody because the hydraulics will win. the human will not. So you want to make sure nothing's going to just start moving when you initially turn power on. That's what these checks are for. So gear and flaps. And then over here, something that wasn't on the list, but you'd also probably want to make sure like the windshield wipers were in park or off at least. That's on most other checks, but I know, and thinking about it now, it's not on this one. So we'll check the windshield wipers too. And then the main thing is the hydraulic system. So we want to make sure the hydraulic A and B pumps are off, and the hydraulic brake interconnect and ground interconnect switches are off and guarded. So with all those in place, we can come up here to the battery switch, and we can see we're on battery right now. We can see we've got around what looks like 28, 29 volts, something in there. So that's a good amount of voltage for us. Battery switch will go on. And right now the system is, the essential power is in standby. I think this light is supposed to be off when we're in standby because we're using the standby source, because this is saying it has no source, and right now it has the battery source. It's not ideal, but it's got something. So I know in the FlyJ sim this light would go off when you were in standby, and so I'm curious if that's correct. That may be a that may be a bug, not a feature. I don't know. We'll see. There's a lot of things that I have to still dive into the manual on and kind of really understand what's going on. All right, so with that set up, we're going to come right over here on here. We could go to external power at this point. If you want to do external power, you get that by going over to the what we call the PFB, the paper flight bag, as opposed to the electronic flight bag. And it's all paper because it's old school, which is super cool. I love how the page turns too. It's really neat. But over here, you could add a ground power unit. We're not going to do that. We're just going to go straight to APU. But if you did that, then that would be available for you. Okay, so we're going to do APU. If you did, once you had ground power connected, you see this light come on, and then you could flip the switch up to on and put the essential power over to external power. You'd hear a nice thunk as the relays kick over, and you'd have power. All right, we're going to come down here to the APU panel, though, which is over on this wall. And we need to run a fire test first. So we're going to put the fire test up. The mouse doesn't change like you hand like in other ones, which doesn't cue you into knowing this is a editable button. And in this case, because it's a 3-position switch, test, off, and reset, just clicking it doesn't do anything. You can click and hold and move up and down, or you can scroll up and scroll down. But you have to know it's available and then use your mouse accordingly. Which I don't like. I wish it would at least change into a hand or something so you could know there's a switch here. But yeah, it's not very intuitive. So we're going to do that. We hear the bell, we see the light, and we reset it. And what that does, that disconnects the fire system, and then we reset again to reset the fire alarm system and re-engage the starter circuit. If you don't reset twice, you're not going to be able to start your APU. All right. APU is all ready to go now, so we're going to switch that to on. The generator light comes on because it's out right now. Lights mean bad. And then we're going to go to start. And it's going to start the APU sequence. You're going to start to hear it. There we go. And remember, it's not all the way in the back. It's just underneath the floor here, so it's fairly noisy. It does get a little bit quieter if I close this door. See that? Isn't that kind of cool? The sounds in this bird are so cool. We're going to let that get into the green and stabilize. All right, that is stable. And we can go ahead and close the field. Hear that thunk as it switches over. It's on the bus ties now. And now we can put the essential power on that as well. That light goes out. So anytime the essential power is supplied some sort of power source, that light should be out. And that's why I think that should be out when we're on standby. Unless it's just to tell you, hey, warning, you're on standby power. You're just battery. You're not going to last very long. I don't know. I could see it going either way. So real 727 pilots can chime in and let me know. All right, once we have power established, the next thing we're going to do is switch on the galley power. You could do just 1 and 2 if you want, since it's cargo. There's no passenger cabin, so it'd really just be for like the kettle for the crew that would be on the other side of this wall here or something. So there's not much to do there, but we'll just flip both switches on for now. And then immediately turn around and flip the radio master switches. This is one that's tripping people up because this is not on the checklist and it's not a visible area, and none of the circuit breakers are modeled to be switches. So these being available are kind of a misnomer there. So yeah, your radio nav won't work if you don't flip those on. So it is in the procedures manuals from like TWA, but it's not in the checklist. So that's a big one. So galley power and then those switches. At that point, we're going to come down here and we're going to do an oil quantity test, because we want to make sure good and early that we got good oil quantity for all three of our engines, because then we'd have time to get maintenance out here. And it looks like we're good. I think 2.5 or 3 on these is the min. Again, I'm going off the top of my head. I haven't delved too deeply into the manuals yet, so don't test me on this stuff. Something else to be aware of, this green light down here means your hydraulic standby system is in use, and that means something up here is not powered with your typical hydraulics, and I can tell you right now that's system A. This is defaulting to off right now. We're going to deal with that later, but be aware your rudder system A's are off when this starts, and that's why that green light's on. We'll come back to that. We're going to go ahead and pressurize the B system, which is going to handle things like brakes. And so hydraulics go on. We'll see the pressure go up. Once the pressure's up, go ahead and turn one of these off. It doesn't matter which one. You only need one B pump on. And the only times we'll have both of the B pumps on is when we're taking off and landing. Every other time it'll be one pump, and we usually alternate between them. You can alternate within the flight, or you can alternate by eastbound, westbound, or the day. The TWA manual said on westbound flights use number 1, on eastbound flights use number 2. But that's an SOP thing. You can do whatever you want. So we're going to do that. And the interconnect stays off. The A pumps can go on at this point as well. They're the engine-driven pumps, so that way when the engines kick on, they'll start running. But we're not expecting them to turn on. We're not expecting them to have power. So we take care of the hydraulics. We come over here to the front, and we're going to hit the nav lights on. We're going to come down and look at the pneumatic and hydraulic brake accumulators. See that they're both good and have pressure, and verify our parking brake is on, and if it's not, set it at this time. You have chocks on right now, so we could have the parking brake off, but this is when we'd go ahead and set it if it wasn't on already. You can also just clear this flashing autopilot light. That's just a nature of power booting up on the aircraft, and you can just clear it. Okay, once we've done that, now, before we do the whole scan of the flight engineers panel, we're going to come over and do a quick thing with the APU panel. And then we're going to get the stuff boarding, and then we'll do the APU panel loadout just for time's sake. So we start up here with the... actually, you would normally start with the circuit breakers, but since they're not modeled to do anything, we're not going to worry about them. And we're going to start with the fuel dump panel. We want to make sure all those switches are in off, and we test these lights by clicking on them to make sure we don't have any burned out bulbs. Okay, that's the fuel panel tested. There's nothing to do with the flight recorder because it's not modeled to work. I think they're possibly going to make this modelable. I was talking about in the Discord, so we'll see if we get that. Next, fire detection. Want to make sure all the loops are on A and B. And once we've done that, we come over to the front again, and right here is the fire test. We want to see 1, 2, 3 lit up. We want to hear the bell. We want to see those 3 lit up. And then we want to be able to silence it. I'm going to click that there, and then reset. And those lights are out, and that's a good test. We've already messed with the fire on the APU, so the APU we can just leave alone. The leading edge flaps, click that over to verify all those lights are working. And then finally the annunciator panel right down here is we're going to make sure that's all on. Now before we come over to the rest of the panel over here, we're going to come out here and we're going to open our cargo door. So we have to turn on the Power Master control. And you can open this on just the battery, like even without turning the battery on the airplane. It's got connection to the battery itself, and but they recommend no because it'll drain the battery pretty good. So you can, but you shouldn't. And but of course in this simulation I don't think it will matter, but you know, hey, we like realism, right? So hit open, you hear the servos go, and there it goes. And doesn't that just sound so cool? Absolutely beautiful. All right, so that guy's going to open up. While he's doing his thing, we're going to come up here to the pilot's seat. I'm going to open up the PFB, and we're going to go over to pre-flight, and I want to get my stuff loaded. So put your SimBrief username in here. Otherwise, you can just set the stuff yourself. And we're going to click that button, and it's going to bring in our load. You notice we are taking full fuel in this flight, and we have a good amount of cargo too. So we're like stretching the limits of what this aircraft can do today, which is going to be kind of cool. But SimBrief didn't balk at me, and that's with the reserves and stuff, so we should be okay. But we are full everything. So to load this, we just simply hit the little play button right there and the play button right there, and it starts to load it in kind of like a real-time kind of situation. What you can do, though, is if you want to just insta-load, once you hit play, come over here and hit this fast forward, and it will instantly go. I'm not going to do that right now, but if it's not done by the time we're ready to go, I'm going to hit them. But for right now, we'll just let that load. But I want to get that started for that reason, so as we're doing our checks, it's doing stuff in the background. All right. So now that we've done our initial power-up, we've done our initial electrical power-up, our hydraulic power-up, our fire test, and our APU panel. Now we do what's called the U-scan on the Flight Engineers panel. That is, we come down, we start up here at the top, we work our way all the way down, go across the bottom, work our way back up, and then we add a little bit of a down the middle to get this little section in here. So I call it the U and then some, or the U dip, maybe U and the dip. And so we're gonna start up here. Again, we already checked our battery, but we can look at the transformer rectifiers, essential TR right here, and make sure we have good volts and amps on all of these things, and they all look okay. Coming down, verify your galley power is on. The CSD lights at this point should be on because we have low pressure because the engines aren't running. So this is a bug I've alerted them to, so hopefully that gets fixed. But we'd want to verify these lights are working. If they're not on already, we push them to verify they're working. Coming on down here, we should see the bus tie lights out because the APU is running all three buses. The gen lights are on because the generators aren't working. But the fields are out because that relay circuit is closed. Not that it matters because the engines aren't spinning and therefore neither are the generators. But we're just making sure the panel looks like this. Should be 3 off, 3 on, 3 off. And that's a normal setup for that. You want to make sure your meter's on an APU, so you're monitoring the APU volts and frequency at this point. Coming on down to the fuel system, we want to check the the gauges. So we hit this fuel quantity gauge. They spin down to 0 and then spring back. This one's going to spin down to 0 and spring back. And this one spins down to 0 and springs back. Now, I'm not sure about what the reasoning for this next procedure is, but it's in the TWA manual, so I'm thinking it's just to kind of pressurize the manifold, and that is to engage one pump on each tank. We can verify, and it's also a nice check to verify that you have at least one pump working on each tank, I guess. And then you have all your cross feeds open. We're then going to close the 2 cross feeds on 1 and 3, verify the valve transit light works. We can close the number 2 just to test the valve, but then we're going to bring it back open. So your fuel should initially look like this. And then we're going to go ahead and open these fuel main valves so the engines can get fuel. Now, in our case, we're going to be max fuel today, and so I'll set this up when the time comes, but we're actually going to be running with all of these open, and we're going to be burning out of the center tank first. The way this works is you burn the center tank down until it equals the outer 2 tanks, and then you would burn tank to engine from each one of the center and left and right tanks. But because we have so much fuel today, we're going to be doing that a little bit differently. But if you're doing a lot of kind of normal or more normal short flights, you'll probably be equal amounts in each engine, or sorry, in each tank, and you'll just be on tank to engine from the get-go. So we're going to go ahead and turn those pumps back off now that that's all set up, and we'll re-engage those when we get ready for engine start. We can come down. The radio panels are, at least these top button switches are synced to the FO, captains, and flight engineers. So if I turn this one on here, it turns it on for the captain as well. And so the way I like to run when we're on VATSIM, and I just do it out of habit, is I want to hear VH1 and VH2. I want to have the interphone on. I want to make sure the volume is up. And we're transmitting on VH1. So we're just monitoring 2, but we're transmitting on 1. In the stuff below here, I don't believe translates over. Well, let's see about the nav one. I don't remember if I checked that one or not. Oh yeah, that one does too. So it's the knob here that doesn't transfer. The knob and this guy is not coincident between those guys, so whatever. Fuel heats, we're just going to make sure that all the lights are working. We're not going to mess with them, make sure the fuel heats are off. This is a gauge that I have noticed I don't ever see move, so I don't know that this is doing anything at the moment. Again, another thing for FSS to take a look at. We'll check the light on the hydraulic interconnect, but we're going to leave it guarded. Verify your hydraulic system A pumps are on. Verify the overheat light. Verify all the hydraulic quantities. So these guys are full. This guy's pretty full. Overheat lights are verified. We had both these on earlier, so we know the lights are working. And or both off earlier, I guess that's what those indicate. And then we can test the overheat on that one. And we know that light's working because it's in standby right now. We're going to put the CSD oil cooler to normal. We're going to push these lights to make sure they're all working. We're going to test the annunciator panel, and then we're going to test the engine vibrations. And these should go, I think it's between 3 and 4.5 is where those needles should stop. And then they'll spring back to 0. It's kind of funny. They like smoothly go up, and then they just like instantly back to 0. I think that's kind of a goof they're going to fix too. There's a mislabel here on the light panel in that says circuit breaker, but you can see the backlights on the circuit breaker are on. And if I turn the panel, nope, it's not that one. Which one's the panel? Which one is the one that's the circuit breakers? One of these is, I think. Maybe not. There it is. So this one that says bright, that should be the control, I think, for the main light on the panel. And that's actually the circuit breaker. So there's some mislabeling or some attachment here. But this guy here that says circuit breaker is actually the backlight for the FE panel. So we'll put that up. Now you can see the backlights on. We do have the nice bright flood there. And I don't know now. I'm curious if any of these turns it down. Nope. So I don't know what those guys are doing, but we don't need that right now, so we're gonna leave that off. Coming on up, we got the pressure differential, the air pressurization controller, and so for this we need to know our altitude. So I've got filed for us today 30,000 feet initially. Our landing altitude in Oakland, we land like around the water, so it's going to be basically 0. I'm just going to put like 10 feet. So we'll put 10 feet. Man, we'll put 20 feet. Why not? To get our cabin altitude, though, we need to look at this little chart and see 30,000 we find 30 right here is 3.6. Let me zoom in a little bit so you can see what I'm doing. So this is your altitude in feet, 2224. So flight level 220, 240, 260. Obviously the line in between would be 23, 25, 27. Sorry, 23, 25, 27, 29, and so on. We're going to be 30, and so that's 3.6. So we come over here to cabin altitude. We're going to put this down to 3, and then we're going to rotate this to 600. So that's going to be what our cabin is going to pressurize to, is 3,600 at 30,000 feet. Want to make sure our cabin rate is right there in the center. Should be straight up and down. The pack valve is closed right now, or sorry, the manual system is just, it's either in closed or open, but we're not in manual, we're in auto. What we do want to do is check this and make sure the outflow valve works. Now to do this, you want to have 2 conditions. Either the packs are not yet running, which they're not, or you've got at least some doors open, and we got a big giant hole in the side of the aircraft for that cargo door, and our main door's open, so we can do this. We're going to go down to check, and it's going to set the system into standby. You're going to get the auto fail light, and the outflow valve is going to close. So what this is doing is testing the workings of the outflow valve and making sure that that is working properly. So that's going to go all the way to close. Once it stops, we put that back in auto, and it should, because we're on the ground, go back to full open. And this right here switch, the flight ground switch, this is what is basically telling it, hey dummy, you're on the ground, you better be full open. There's no need to pressurize right now. Once we seal up the airplane and start taxiing, we'll move that to flight and it will start to pressurize the aircraft. Alright, coming on up, we want to put our air conditioner controller just into auto, which is straight up and down. It's actually, everything up here on this top half is auto, but it's auto. This is, I think it runs from, what is it? It's like 70, it's like something between 70 and 80 degrees, or 65 to 85 degrees, I think, is full cold and full warm. And anything up here, the auto controller is going to manage that temperature in theory. There's some issues with what the air mix valve shows right now. The whole pneumatic system is getting overhauled, so we're going to play with it like it matters, but it really doesn't to a large extent right now because it's not functioning quite correct. But you can check your main supply, your aft supply, forward supply, all that stuff, and that would show up here on the temperatures. But it's not running yet because we haven't done that yet. Check our duct overheat lights right there by clicking on them. Up here we can check our trip off and our autopack armed green light there. And then here we're going to open the APU bleed and the engine 2 bleed. We're just going to open those back both up so that way we've got flow to both packs. And we're going to turn on the engine bleeds. Now right now it kind of forces air in when I open the outside bleeds. Shouldn't happen. Again, that's part of the overhaul that I need to get done. But on the manual it does say the TWA manual does say you open all these up in the beginning and you just leave them open. We will turn these off after engine start. So once those are up, we want to open the cooling doors full open. The main thing on this is to keep your pack temperatures in a certain range, but the guy whoever had the FE manual wrote in, when he was taking notes, when he was learning how to fly this airplane, or how to fly the panel at least, that the easy shorthand for this is at 10,000 feet, change these to half open. At 18,000 feet, between 18 and 20,000 feet, go to 3/4 closed. And then at cruise, full closed. And then when we start descending, we go to 3/4 open. When we get to 18,000 feet, we go to half open. And when we cross below 10,000, we go full open until we land. So that's how we mess with those cooling doors. With those open, we can go ahead and turn a pack on. You always want to turn these on one at a time and kind of let the cooling fans start up. There's a lot of amp draw initially. You don't want to accidentally trip off the APU or something. So you turn one of them on, let it kind of spin up, and then we'll tip the other one on, and we'll get our packs going. And then we can turn on our Gasper fan and our cargo heat outflow normal. So all of these switches basically go full up is the part of the start. We just kind of do them slowly and methodically, make sure we have manifold pressure there. That's the U. Now we're going to do the dip. So the U dip. And we want to look at our oxygen pressure for the crew. This needs to be at least 1,200. For the cabin, for the passenger side, it needs to be at least 1,500. So we're good on both fronts there. That's good. We're going to check that light. Oxygen system should be in normal. Cutoff, the pack trip cutoff should be in cutoff for right now. We'll turn that to normal before takeoff, and then we'll turn it back off after takeoff. I'll explain what that is in a little bit. Aft cabin zone temp overheat, we'll check that. We just want to make sure this valve operates, so we're going to just pick a side, watch it start to move. Once we verify it is moving, then we put it back to right where it was and just leave it alone. That's all we're doing with that one. Start valves, we'll just click the lights, make sure the lights are working. Down here, the wing anti-ice overheats, you can test all three by hitting the test light. And on this one, we go to ground test, trips up, back to ground reset, and back to normal, and that's good. And that is the flight engineer's panel all ready to go. So it's a lot of stuff, but it's actually, you're actually not doing a ton. It just kind of feels like a lot. All right. So we can actually go over and look at the engineer part of it, which I think is what this is. That's why it's boxed. Well, no, maybe it's just like the important stuff. I don't know. I'm not sure why it's boxed, actually. But this is before start, so we can kind of look at these and see. I'm not sure. This says pilots. This says engineer. Oh, yeah, so this is engineer. So this is all the stuff that we just did for the most part, so we can just check and see. So batteries on, fuel quantity. We are fueling right now, so we'll check that in a little bit. The boost pumps, they say one on each tank, but this is before start, so we're actually not quite ready for before start yet. Cross-feed valves set up, B pumps all on, because that's going to be, so this is actually, we're premature for this because we're not ready, so we're not going to deal with that right now. I was going to see if that was like a safety check kind of thing, but it's not really. All right, so the engineers panel is done. We're going to come back over here. First of all, check and see. Our cargo's finished. Fueling is almost finished, so we're almost ready to go there. We're going to come up to the overhead panel, and we're going to do kind of a standard strip scan down this thing and get everything ready. So hydraulic power, all these are guarded and closed. This is the only exception. If you open these, you see they are actually off, and we'll put those back on. These are actually on standby. They actually should be off. It's standby is on. It's kind of a weird backwards kind of system. But if we go back to the flight engineer panel, you'll see now that green standby light is off. So that is how it should be. Coming on down, the anti-skid we leave off until we get to the runway, so that's fine. We'll leave that where it is. Stall warning, we can test that. You can hear the stick shaker going. And we can test the light. We actually don't need to test these lights because we're going to test them all in a second. They'll come on. But we can test the flight recorder. Compass should be slaved, and the heading set. The instrument comparator is these guys right here. These will light up if you've got an instrument disagree between one of these things. And it's kind of a bear to test this because if you click on this, now you can't use your right mouse or your other thing to move your view. I have it set to a hat switch though, so I can look down, and you can see those guys light up. So it's kind of an interesting one to test. I'm wondering if there's a better... I guess you can come back here and do it. Yeah, so you could do that. Your VHF nav and compass should all be in normal. So that's assuming the FOs and captain sides all are working correctly. You have a cargo fire test. Hold that down, make sure we get the bell. And those light up forward and aft. It was very subtle, but they do light. But just like a yellow backlight. Auto brakes to disarm. I don't use the auto brakes in the in 727. Not all 727 have them fitted, and so I just kind of like to pretend that it's an older one and doesn't have them. So I don't even use them, but they're in disarm. If you're taking off, you do want to put those in RTO if you're going to use them. Let's see, coming down here, windshield wipers set to park. Emergency exit lights, make sure we arm those guys. In the passenger model, you want to do that before you start boarding people. Engine start switches up here are all guarded. The alternate flaps are guarded. The compass on this side is slaved. The microphone test for the flight recorder, we hit test and we wait 5 seconds and make sure that needle doesn't deflect backwards at all in that 5 seconds. And the amount of time I've been talking, it's been about 5 seconds, so we'll go ahead and let that go. No smoking light come on, seatbelts come on when we're about ready to move the aircraft. Passenger address system, you can turn the speaker on so we can hear in the cockpit, but again, it's not a passenger model, so I don't know who we're talking to. We're going to set this to 2000 since we don't have, we're not on VATSIM today. But you would set your squawk code here, either system A or B, and then when you're ready to start moving, we turn this on and then go to TARA eventually. We'll treat that like we are on VATSIM though. Window heats up here, we're going to turn these all on. Verify we got good lights, and then we're going to do the overheat test, and that's going to switch over to these guys, and that's a good test right there. And then we're going to reset them by turning them off. We're going to leave them off until engine start because it's a big draw on the electrical system. So unless it was like stupid cold outside and we needed them, we leave them off. Anti-ice, you can double check the light. This should be on engine number 2, but you can check and see if this needle faults out on any of the other engines. On the wing anti-ice and the wing and engine anti-ice down here, we're going to turn all 3 of these. No, we're not. Sorry, we're going to turn on to left, and then we're going to open these, and we should see them go off while they're in transit and then come back on. And then we're going to check all 3 positions and then check the wing. We should get lights on the wing, and then go back to the right side, and we're going to flip them again, and again we should see them go off and come back on, and then all the way through all 3 and finally off. And that's the completion of that test. And then for the pitos, we're going to turn those on briefly, verify all the lights go out, and then turn them back off, because again, not till after engine start, we want to turn those on. Any other cockpit lights you want to set up, you can do that this time. Nav lights should be on. If it was dark, we could do logo lights. Dome light is right there if you need it. The red flood is not quite working right now. You can turn it on by hitting L and it'll turn all the lights on, and then you turn off what you don't want. But that's the only way to get the red light right now. And they are fixing that, so that's a little bit of a bug. And then you also have the panel flood here, but at night that's actually stupid bright, and so it's not very, it's kind of more useful in like dusk hours, I think, or once you're on the ground doing your pre-flight. Okay. Coming over here, we want to double check our radio panel. This should be into microphone number 1. Everything, and this can be on both. Everything else is set up already. You can do your airspeed test. Now check this out. When we put that back, we go to the B system. It sounds slightly different. You hear the pitch change? So there's 2 of them. So you can decide which one you like better, I guess. That's if you're overspeeding your aircraft, that'll come on. We need to set our baro, and to do that, I'm going to look at the weather here in Jacksonville. And it looks like the current baro is 299.6. So we're going to set 299.6. Oops, that's 7. There we go. And we do have to do it 3 times. They are, I think one of the things they're going to add is a sync up between these. But it is kind of, again, in these old school birds, it's kind of fun to do it. In the MD-11, it was really important because this could throw off your autopilot. Here, it's just, it'll throw off your reference, but it won't break anything. I'm going to cage the standby artificial horizon. Just hold this guy right here until it stops bouncing around and goes stable. And that's good right there. We can set our initial cruise altitude, which for us, we don't have any ATC, so we're going to bug this all the way up to 300. And we also want to make sure, depending on what you're using, if you're using a GPS system, make sure that you're on GPS, but we're going to be using old school nav, so we're going to leave that switch on nav right there. And then we can test our lights. This is also going to test the Whaler on the autopilot. So you see all our lights coming on. And now we can see the lights up here too, so that's why I said you didn't need to push these. You technically can do all these back here that way too, but technically we wouldn't be sitting at that station, so that looks good. If you go down to the dim position, they're dim, and you don't have to hear the Whaler. So you can do this sans Whaler and dim lights if you want. We're just going to go ahead and put them back to normal now, and that's a good test for that. Yaw dampers are in and guarded. Those are all checked and good, and everything looks good over here. I don't think this is, yeah, the ground proximity is in normal. You can hit this to illuminate that. The system test doesn't seem to do anything at the moment. Oh, no, there it goes. I wasn't holding it long enough before. Okay, and you got to hold it for the whole time. So you do start to get it. What do you know? Learn something new. Okay. Yaw damper ground test. I don't know. This is something I'm not sure what's happening here. I'm going to have to read up on that one because it just goes between upper and lower. I don't know how you actually test it. If something's supposed to be happening there or not, I don't know. All right, the INS, we're going to get this up in programming because we're going to show you how to use this guy. This is fun. I love this kind of old school flying. So this is called, we call this the CIVA because it stands for, it's a Delco Carousel 4 A. Delco Carousel 4-A. And so CIVA is the carousel, C, 4 in Roman numerals is IV, and then the A, so CIVA. So we usually just call it the CIVA, or the CIVA, and, but it's a Delco carousel unit. And we're going to turn it to standby. That's going to boot it up. And you can either turn it to align right away. I like to leave it on standby until I'm ready to start aligning it, just because I don't want to enter something wrong and have it start to align on bad information. So either way is fine, but the main takeaway as of right now, don't start putting waypoints into this until it's fully aligned, because that apparently causes problems. So you have down here this rotary knob, and you've got a number of positions. So we have desired track / status, we have wind, distance and time, waypoint, position, cross track, and track error, I think this is. I can't remember what the TKE is. You have heading and, shoot, I don't remember what the DA stands for. And then track and ground speed. You can tell the ones that I use versus the ones that I really don't use very much. Then down here you have auto and manual, and this will allow the system to automatically switch from waypoint to waypoint, or you do it manually. I have noticed it will not switch from waypoint to waypoint unless you're actually using this tied into the autopilot system, so be aware of that. And it says test here because you would normally press this to test it, but that's not modeled apparently. Beyond that, you've got a remote button, which is not modeled because normally you'd use this to be able to program multiple INSs at once, but as you can see, we only have one, so the remote has no function. The insert key, you've got an alert light, a battery light, and a warning light. Number pad, which you'll notice has north, south, west, east on it, as well as frequency, DME, and I don't know what the LL stands for, but it has something to do with the level, I think, of the DME/VOR for syncing it up. So we'll be using some of those features during this flight. I'll show you, in addition to the zero key and the clear key, obviously. And then you have the waypoint selector, which is a little rotary knob that goes up to 9, so 0 through 9. Leave that on 0 for the moment. And then you have the from to, which will show from one of those waypoints to the other waypoint. And something to note here, though, you can't run this backwards. So you can't go from, like, say, waypoint 7 to 6. The system won't let you do it. If you put a 7 here, you can only put an 8 or higher. It will go from 9 to 0, from what I can tell, but I wasn't able to get it to do the other thing. At least it wasn't doing it for me the other day. So if it's supposed to be able to do that, that might be a bug. But generally, you don't want to go backwards on your route anyway. But you might find you want to skip ahead a bit. And so as long as you're not skipping directly behind you or something. I don't know what its logic is and why it doesn't allow you to do it, but it is what it is. All right, so we need to put in our present position. So we're going to go to position, and we get our latitude, longitude here. And this is looking for degrees, minutes, and decimal of minute. Normal lat long is laid out as degrees, minutes, and seconds. And Navigraph specifically gives it to you in degrees, minutes, and seconds. So it's not a straight translation over here, and I'll show you what I mean by that. So let me show you the flight plan, because this is going to trip some people up. So let me go ahead and do this. So you see over here on our flight plan, we've got a number of waypoints. So this is the Craig VOR, for instance, and you can see it's 30 degrees, 20.3 minutes. That's how you read that. Now, if I look at the Craig VOR in Navigraph, which is right here, and I click on that guy, and we can see the coordinates, you can see 30 degrees, 20 minutes, and 20.0 seconds. But we need it in 20 point something minutes. So you have to ask yourself, how many 20 seconds is what percentage of 60? You have to do that conversion. So the easiest way to do it is just take 20 and divide it by 60. And it will tell you real fast what it is, and you round it to the nearest whole number. And that's the decimal. So in this case, just to do the calculation for you, because it's easier when you see it, we would take 20, divide it by 60, because there's 60 seconds in a minute, and it's 0.33333333. So we would round that to 0.3, and that is the decimal. So it would be 3020.3 is what we're going to put there for the Craig VOR. Now the flight plan will give it to us that way, so we don't have to worry about that. But if you don't have, if you're not using SimBrief, or if you need to get a coordinate off of something that wasn't on your flight plan, chances are you're going to find it in this format, and you're going to have to do that conversion. If you put 20.2 in there, you notice that's different. And depending on where you are in the sequence, this can be different by quite a bit. So if this was, let's say, 30.3, or sorry, 20 degrees, 20 minutes and 30 seconds, that's the equivalent of 20.5, because 30 is half of 60. So you can see how that can get wonky and off really fast and can make your stuff not very accurate. Okay, so what we're going to do is we're going to put our present position in here. To find our present position, there's a couple ways to do it. And the dirtiest way to do it, I'm gonna go back to the tablet here. The dirtiest way to do it is to take the airport's number right here, 3029.6, which this actually is in the format you want, 3029.6, 81, 41.3. So that format's okay. But that is not where your airplane is sitting. That is that point right there, that little target spot. That's the roughly center of the airport, or wherever they decide to measure the airport from, is what that point is. So you can see we're sitting over here. That's not quite accurate. It's not bad, but it's not terribly accurate. The better way to do it is to use a parking stand coordinates. But you may not have this. Like, this gives it to us for all of the passenger parking stands, but I don't think it gives it to us for anything else. And no, it does not. So we don't have any of the cargo stand parking spots, so we don't know. Now, in a modern airplane, the GPS would just show us, hey, this is where you are, dummy. But we don't have that in this aircraft. So what we can do is, if you have Navigraph, you can zoom in on your little plane here. If you right-click on your aircraft, it puts a user position right there. And look at that. There is our point. Now, you're going to have to convert this one, though. So it says 30, 29, and 8.7 seconds, 81, 40, and 53.7 seconds. So we're going to pull out our handy calculator again. And we're going to find out that 8.7 divided by 60 is 0.14. So we round to 0.1. If it was 5 and up, we round up. If it's 4 and below, we round down. So 0.1. So it's going to be 29.1 on that one. And the other one is 53.7 divided by 60 is 0.89. We're going to call that 0.9. So 0.1 and 0.9. So over here, we can go, we hit north first. We got to tell we're in the northern hemisphere. And we are going to put 3029.1. And we verify 3029.1 insert. Now this little thing tweaked over here, we're going to put west, because we're in the western hemisphere. And we're going to do 81. You don't need to worry about the leading zeros. 81, 40, and I said 0.9. So 81, 40.9, and insert. It now knows where we are, pretty dang close on the ramp, and we can now go to align. Move this guy over to status, and we see we're currently at 9.5. This is going to count down to 0. The 5 is going to stay. It's just going to be this outer number. When this gets to about 3, that nav ready light's going to come on, but you really should wait until this gets down to 0, which is your highest level of accuracy. The bat light comes on at 8. That's a test it's running internally. That's normal. Don't worry about it. It goes out. And normally this unit would take a lot longer to align. Right now it's aligning way too fast. That's fine, because it works in our favor for the moment. But we're going to let that run down and align. While it's doing that, we're going to set our first couple waypoints, because we're going to be navigating via radio frequencies here. So to do that, we're going to look at the Jacksonville 7 departure, which is this here. We have to use a non-RNAV departure. Even though we have an INS, it is not rated for use in the terminal area. So it means it doesn't work for SIDS and stars. Now, this is a sim, so you can do as you want. But if you want to be realistic, you don't use the INS for the SIDS and the stars. So if you're filing on VATSIM, you're not Slant Lima, you are Slant Whiskey or Slant Zulu or something like that, but you're not Slant Lima. You can't do RNAV SIDS, you cannot do RNAV stars, you can't do RNAV approaches. You're limited to VOR approaches, NDB approaches, ILS approaches, and conventional radio navigation and vectors. You can do RNAV points en route, so what we call en route RNAV. And that's where I think Slant Zulu specifies that with an INS. So you can do that, but you're not equipped for SIDS and stars, if you want to be realistic. All right, so our first waypoint out of here is actually the Seminole VOR, because we're going to be going this way. However, I'm going to use the Craig VOR to draw that line, also because I don't think I'm going to get the Seminole VOR out of here anyway. So we're going to fly an outbound off of Craig and when we take off initially. Now, normally ATC could vector us over there, but because we're flying offline, we have to plan to do this ourselves, so that's why I'm going to do that. So 14.5 is Craig VOR. So we're going to come over here to our nav equipment, and we're going to say 14.5. And then the Seminole VOR is 117.5. I'm going to put that in the standby. It's really important when you're flying this way to be as ahead of the aircraft as you can, because you will find it goes by fast. And you'll be doing this constantly. It'll keep you active and going, and it'll feel like you're doing something the whole time. The flight will go by so fast. It's really cool. 17.5 on the nav 2. And then the third one is going to be our waypoint after that, which if we look at our flight here, we can see our next waypoint is going to be the Crestview VOR, which is 115.9. So we're going to set 115.9 on this one. All right. So what this has done for us, it has put up the primary VOR we're going to fly outbound to. It's going to put it's going to have the second VOR in our standby, so we just have to flip a switch to change over. Really easy. And it's going to put in the nav 2 our VOR we're going to be flying to, so we get the from and the to, and we'll see that over here. So the primary line, the 1 line is our VOR 1, the 2 line is our VOR 2, and then in the standby of the number 2, we have the third VOR. So once we start flying to this other one, we switched over, we can click that over, and then we can see when the next VOR becomes active. And we just keep switching back and forth all the time. So we're always keeping those guys filled until we get to Oakland, and we're doing those checks all the time. And then we're going to back that up with the CIVA INS. So you see the green light here is on now. We've got 0 on that. We can switch this over to nav. That light goes out, and we're in nav mode. Don't touch this anymore, or you have to start over. That would be bad. So you want to move this selector switch now. 0 is us. We are 0. So don't ever put anything in 0 ever again. We're going to go to 1 now. We're always going to deal from now on with 1 through 9. Those are our waypoints. And if we run out of space, then we program mid-flight. We're going to go back now to waypoint. We want to put a waypoint in, not our position, our waypoint. And we're going to program in the waypoints we want. We're going to start with the Craig VOR because we want to be able to fly outbound on a course. And in case something's not popping up, we want to make sure we have that. So I'm going to be going over and reading off this list, and I'm going to show you entering these things. We are not going to put in, so we're going to put the Craig VOR in. We do not put in the top of climb point. That's not an actual nav point. That's just a reference on our chart, but it gives us an approximate location for it. So, but don't worry about that. We're going to put in the all these VORs, and we do have a point or two later on in the flight that is an RNAV point right there, and Lando right there. They're en route, so we can do that. And then finally, and we actually can find those with the VORs too. I'll show you that when we get to those points. We're not going to put in our top of descent, and then we're not going to put in anything after our. Let's see here. We're gonna cheat a little bit because of the, and I'll explain that en route actually, because we're not going to get there anyway in the programming part of this. Normally you would put the beginning of your star and then the airport, and that's it. We're actually going to put in the final approach fix as well, and that's because we're technically supposed to have radar coverage or RNAV capability to find that point. And you would normally always have that in the real world because it's a controlled airspace area, but we're off VATSIM today, and so we need a way to find that. And we could also just dead reckon it, but you know, we got an INS, why not? Why not use it? So, so we're not going to do that. So we're going to put in the first 5 waypoints. So we need to put in Craig first, and that is going to be north, let's see, 3020.3, 20.3, insert, west, 8130.6, 8130.6, insert, verify that's right, and on to the next one. Next is going to be the Seminole VOR, which is 3033.4, north, 3033.4, insert. Now you notice it changed to west already, but we still have to hit the west key. Don't look at that and go, oh, it already is the right one. You always hit north, south first, and east, west first before you put in what you need to do. So we're going to hit west for the Seminole, and we're going to do 8422.4, 8422.4, insert. Next one, number 3, is the Crestview, 3049.6, north, 3049.6, insert, west is 8640.7, 8640.7, insert, waypoint number 4. It can help. I've done this a number of times, so I'm not worrying about it, but it also does help to maybe circle these on your flight plan or label them number 1, number 2, number 3, number 4. Because if you get out of sequence, it can be hard to remember which one's which. You can go back in here and look at the numbers and compare them to your chart, but you know, who wants to do that? So that's an option. It's kind of a best practice kind of thing. The MCB VOR, which I think is the Brookings or something like that. Or no, it's Mount Fort something. I don't know what it doesn't matter. North is 3118.3, 3118.3. Insert. West is 9015.5, 9015.5. Insert. Number 5 is Alexandria 3115.4, 3115.4. Insert. West 9230.1. Did I hit west already? Yes. 90. Let's see. Whoops, not 9092. So I'm going to clear that back one. West 9230.1. 9230.1. Very important to get those right. 6 is FUZ VOR 3253.4. 3253.4. Insert. West is 9710.8. 9710.8. Insert. Number 7 is the ABI VOR, and that is 3228.9. 3228.9. Insert. West is 9951.8. 51.8. Actually, ABI is Abilene. I remember that. Then we have CME VOR for number 8 is 3320.2. 3320.2. Insert. West is 10437.3. 437.3. Insert. And 9, this will be easy to remember, is one of my favorite VORs in Flight Sim, Truth and Consequences, named after a game show. North 3317.0. 17.0. Insert. West 10716.8. 10716.8. Insert. All right. We have no more waypoints we can put in. It's full. So as we get flying, usually once I pass waypoint 5, then I will start backfilling 1 through 4 again with the new waypoints as we go. We'll do those in cruise. So we just need to know where we stopped. We stopped with Truth and Consequences. The next one is going to be the Phoenix VOR PXR. All right, so that gets us all the way to just south of Albuquerque. So most of it got in there, amazingly. With that programmed, we would go to distance and time. This is how you would check these. Now this isn't working quite right. This should show us the distance between 0 and 1. And then if we change to 1 to 2, it'll show us the distance between that. Right now, it's adding them up. And so we still can test in a way to make sure it's relatively, what we expect. And so what we do, we look at our chart here. And on these ones that are vectored, this number, the first number is going to be kind of superfluous because it just is. Because it doesn't know exactly how far we're going to fly. So on the delta layout, which is what I'm using, this ZD, which is difference in delta means basically difference or change. So and the ZD is the distance. Don't listen to me. That whole delta thing means nothing. D is for distance. I don't know what the Z stands for, but that's what it is, distance. So it's saying 31 miles to the Craig VOR. That's assuming we're going to take off, we're going to fly around, we're going to go to it. And it's just coming up with a number, I guess. So this says 13, that says 31. These aren't going to match. That's okay. The really important one is going to be after that, which is to Seminole, which I can see is 122 miles to top of climb, plus 27 to Seminole. And that's from Craig. So what we're going to do is assume the 13, not the 31 number, because that's what this thing is looking at. It's looking at the line of sight. And so 122 plus 27 should be roughly 149, plus 13 would be 162. So if I do waypoint change 1 to 2, insert, that says 139. Why does it say 139? I don't know. That number didn't match. It's supposed to be cumulative. I thought it was anyway. That's what it was doing before. That looks closer to... So I'm not sure what's going on there. That seems odd to me. Let me double check in Navigraph what the distance is. But yeah, see 149 from Craig. You know what it might be though, because I wonder if it's subtracting the distance instead of, but that still wouldn't be 139, would it? 149 minus 13. Well, it'd be close. I think that's what it's doing, because we got a kind of a backtrack thing going on here. I think it's looking at it from position 0. I think it's taking our position 0 to there. I think is what's happening. So that's why it's giving us 139. So ideally, what would normally be happening here, and again, this isn't working the way it's supposed to, it should look at waypoint 1, waypoint 2, and show us the distance between those two. It's not doing that. It should give us 149. It's not. It's off by 10. I think it's because of this. In fact, if you look at this is a slant range kind of issue, because we're a triangle. We're not directly above Craig. So I guarantee you that's a difference of probably 3 miles as opposed to all 13. And yeah, so that actually makes sense. So because of that, so if we do waypoint change now 2 to 3, this number just keeps getting bigger and bigger. And so you could kind of go through and do the math at this point and kind of like, okay, roughly we're in the neighborhood, but it's just kind of ridiculous to do it that way. You should be able to compare these numbers on the chart. There should fix that. But that's just, it is what it is. So we're going to do waypoint change 0 to 1, insert, that's where we want to start. And we're going to leave it there. I'm going to put this back to number 1. Just, you don't need to do that. It's just what it is. Time shows obviously infinity because we're not moving. So it doesn't know. Okay, all of that, we are ready to go. So I know that was a long time, but this aircraft takes a little while to program. So let's go ahead and close the doors. We're going to put the little thing back. You can still hear it. It's muffled now. And we're going to close this door. The click spot for this is really hard to get to. I don't know that you can even get to it in here. I can get to it by looking out the window. Obviously, you can do it in the paper flight bag. I actually programmed a button through SPAD on my controller, so I can just do this. Because I like the immersion. Oh, it's so satisfying to hear that, to hear that go. With that, we can tell GSX we're ready for push. So bring on the pushback people. Bring on the pushback people. All right, we're going to go to pre-flight over... No, that is pre-flight. We're going to go over to aircraft, and we're going to remove the chocks and remove the cones. And we're going to go to takeoff. And we're doing runway 26. We'll flap 15. That's our weather, get our current weather. And that gives us our V speeds, which will set our speeds. So V1 and VR is 139, V2 is 152. And then our EPR is 2.08 and our trim is 6. Now, if you click set EPR and trim, it will set them for you. But I like to do it myself. So 2.08, I have a button over here that I mapped, or a knob I mapped to hit all 3 EPRs at once. Otherwise, you'd have to run that set knob individually for each one of these, or you can hit the set thing and it'll do it, which is fine. We're going to do 2.08 is our takeoff power setting. So that's set, and then 6.0 on the trim. These notches are all 1, so 5 is right there, so 6 right along with that 20 right there, and we're going to run the trim back. Trim's electric, so we don't need to wait for the engine to be on. We don't need hydraulic for this. We can do this at any time. Trim goes back to 6. Excellent. All right, we're going to do beacon on. So we're going to start moving. Seatbelt sign goes on. And the transponder goes to on altitude. On the FE seat, we're going to do nose to the left. And we'll do that in a second. We'll close the door. We're going to do one fuel pump on, and we do one because it's less drain on the system, on the APU while we're starting engines, and then once the engines start, we'll kick them all on. And you can see now we have a lot more in the center tank, so we're actually going to go tank to engine on all of these. I'm sorry, not tank to engine, but we're going to open the cross feeds for all of these, so the whole manifold gets pressurized. A pumps are on, just want to verify that. Packs come off for the engine start. And that should be good. Now we could run through the checklist here and make sure we got everything. For the sake of time and because this isn't a master class, I'm just going to tell you we pretty much got it all. So we're going to go ahead and release the parking brakes. To get rid of this, click the center thing. Just going to move that out of the way. And we're going to start pushing back. Yep, there we go. And we're ready for engine start. So we come up here. Start sequence is 3, 1, 2. And put that down using the scroll wheel. And we can see N2. We're going to wait till 20%. There is a bug right now. If you let it go much beyond 20% and don't add fuel, the EGT will start to rise anyway. They're going to fix that. Don't worry. But when it gets to 20%, we will go ahead and introduce fuel. I've got that set on my Bravo, so I can click that and the fuel switch goes up. There is the EGT starting to go up. We have light off. At about 40% into the starter kicks out, and I just heard that click kind of faintly. So go ahead and close the guard, and we'll start number 1. And there's 20% fuel on number 1. Brake set. And we got a good start on engine number 1, starting engine number 2. Now, during all this, the flight engineer would be monitoring the oil pressure and temperatures, making sure we got good oil rise, oil pressure rise, oil temperature rise on all of these as they're going. Start valves indicate over here. On the FlyJ Sim one, I actually like to sit in the engineer seat and hit them from here, but there's no way to hit this click spot that I've discovered without maybe being way down here, where I could on the FlyJ Sim. So I have to kind of sit in the thing. And we probably should get the fuel going on number 2. I heard the starter kick off, so we'll go ahead and close that. At this point, we can go ahead, well actually we need to get the electrical sorted first. So the first thing you want to do is the electrical, so then you can start turning on all this other stuff. So in order to do the electrical, what we want to do is set the synchronizer up to Gen 1, and you see it's blinking. You want to see no lights. Synchronize means no lights. We're looking at the frequency right here, and we're going to adjust this knob, and the lights go out. And so straight up and down is generally what you're looking for anyway. With the lights out, we're going to close that generator, and it's going to stick that on the bus. We're going to switch that to Gen 1, so we're off of standby. We're going to run this on Gen 3, but we're going to do that just while we start them. We go over here to Gen 2, and you can see it's already synchronized, but the needle's a little off-centered. It's not perfect. This should very faintly be blinking when it does that, and what you would do if that was the case, as soon as they went full dark, that's when you would cut the generator over. So we're going to go ahead and close that one. You can see the needle moves a little bit, so they should have been very slowly blinking still. That's just a, very nitpicky for this. And then over here, same thing. You can see we're a little fast, and so we're going to put that there and close. So now all 3 generators are on the bus. We can set this to Gen 3 for the essential power. We'll leave that on Gen 3. And actually, we can just put this onto bus tie at this point, and we'll show all the stuff. At this point, we just come around. We kind of do a U-scan again. We're going to put all of the pumps on. Once we take off, we're going to turn the side tank boost pumps off so that the center tank is just running the entire manifold. But for takeoff, we want them all on. Coming down here, we've got no lights on the A system. We want to put both Bs on right now. So that's going to come on there. We come up here. Pressure controller goes to flight. Packs come back on. Again, let them boot for a moment and then hit the other one. Cooling doors are open and the APU bleed engine 2s go off. At this point, we can also set the cutout system to normal. And we can turn the APU off. The APU is spooling down. This engine cutout is a pack trip in case we have to reject the takeoff. If we have the engines up above, I think it's 1.5 EPR, and suddenly lose an engine, the system will sense the loss of EPR on one of those engines and will automatically trip the packs off to give us as much engine power as we can on the remaining engines. So sorry, it's not a rejected takeoff situation. It's a lose an engine on takeoff situation. I misspoke. All right, so the flight engineers panel is now all set up. We can go ahead and set our flaps to 15. Trim, it was already set. And we can also do the high voltage items. So we can turn the heats on, and the pitot heats can come on now. We'll also do the taxi lights. We'll leave the landing lights until we get to the runway. Do a control check here. Make sure your controls are working. Always important, especially in Flight Simulator, because hardware can easily be disconnected. Check the rudder back and forth. Rudder's working. And we would get our clearance, and we would be ready to taxi at this point. Parking brake off. Here we go. And it will take a little bit of oomph to get going, especially we're heavy right now. So I'm going to give it quite a bit of power, and then we'll back off, and it'll actually coast pretty well once it's rolling. It's just getting that, what they call breakaway force initially, and we can pull that down. You hear the rumble of the engine as we do that. Also cool to kind of note, you can hear the engines sound really cool if you open the window. Isn't that cool? Obviously you don't want to take off like that, but it's just kind of a cool feature that, you know, and it gets quiet again when you close them up. So, because we are well on the way in the back. It's kind of like the MD-80, where you wouldn't be able to hear them very well up here in the cockpit. So they are pretty quiet, and that's pretty true to form. So we got a bit of a taxi ahead of us, so I'm probably going to cut it here and do the taxi, and then I'll see you guys at the end of the runway, because there's no reason to make you guys watch me taxi this thing all the way around. Just do remember, I'll leave you in here for this first turn, and that is that it can be easy to scrub the wheel if you're going too fast, if you go hard over. So just like with a lot of other aircraft, if you find yourself like not turning fast enough and you have your tiller or your rudders hard over, try just backing it off a little bit and doing little short bursts. You'll find a lot of times you'll regain traction and you'll be a lot better. All right, with that, I'll see you at the ready for takeoff spot. All right, welcome back. We are approaching the end of the runway. It's actually a much shorter taxi than I thought it was going to be, because I checked and they changed the runways IRL because of this weather that's blowing over the top of us here. So instead of 2.6, we're taking off on 8. So we have just straight down the taxiway, so it kind of worked out. All of our numbers stayed the same, though, so no change there. I double-checked those to make sure we're still good. So 139, 139, 152 is still accurate for us. We're going to turn over here onto Lima, and then right up here is runway 8. So as we approach the runway, we're going to hit the strobes, and we want to make sure our TCAS is TARA. We don't have any passengers to ding, so we don't need to worry about that. We're verifying our flaps are 15, and we're on the flight engineers panel. I think we've done everything already set, it looks like. Yes. Just trying to stay on the taxiway here. I've got the Craig VOR dialed in already, so we can turn south towards it as soon as we're airborne within range. And the way this works is we're going to run up the engines to our takeoff EPR power, 80 knots. We're going to call out and release any pressure on the yoke at that point. V1 rotate will rotate smoothly back. And the flap retraction schedule in this aircraft has two different possibilities. It is if you're under 154,500 pounds or over 154,500 pounds. We are decidedly over. We're like 184 out of a possible maximum takeoff weight of 191,000. So we're pretty close to MTOW, but we're not there. So we're going to be doing the higher ones. So what that means is two things. Our retraction schedule is going to be 160 from 15 to 5, 190 from 5 to 1, for 5 to 2 rather, and then 200 is 2 to 0. So by 200 we should be fully clean, and at that point we can set climb power, which for us is going to be about 1.8. Quiet EPR in this was about 1.7. If you're under the 154, if you're over it, it's 1.8. So we're going to set 1.8 once we get there. Once we pass about 1,000 foot AGL above the field, we're going to go ahead and lower the nose from about 15 degrees to around 8 to 10 to accelerate so we can retract those flaps. And then once we're past that 200 and we're clean, we're going to go ahead and reduce the EPR value and start climbing at 250 below 10. And then above 10, we'll go ahead and lower the nose again, and we'll accelerate to about 300 knots at climb power. Climb via, we'll pitch for speed at that point with climb power still in. And then once we pass about, let's see, what is it? It's around 20, is it 20,000? Yeah, it's 20,000. Once we pass 20,000, then we'll scale back to 290 knots, and we'll climb all the way to cruise at 290, and we'll transition to about Mach 0.8 for our cruise. Using whatever power is necessary. There's no auto throttle. There is an auto throttle option that's really recommended only to use in cruise. Again, I don't use it, so we're not going to use it today, so we don't need to worry about that. All right, landing lights are on. All of our other lights are on. We got that going. Everything's dark on the engineer's panel, so this is good. We've got all the valves open. All the fuel pumps are going. Galleys on, packs are on. These are off. And we're in flight mode. That's good. The other thing we do right before takeoff, and I mean this is like lining up on the runway and we're ready to go, is you put the oil cooler CSD to ground. It's ground off, and it will spring back to normal once we get in the air. But you just do that for the takeoff run. It's really not supposed to be down there for more than like 30 seconds, so it's really just for the takeoff run. All right, here we go. And in fact, we're heavy, so I'm going to go ahead and hold the brakes, and we're going to spool up all the way to our EPR. I don't know if the engines will actually get to our EPR setting. That's another kind of a little bug, but they'll get close. So we're going to manually push those needles up as close as we can, if not to the EPR bug. Hey, they're going to get there today. And we're going to back off number 3 a little bit because we're a little bit over that EPR, and same with number 1. Got to watch that. This is where the flight engineer would be adjusting these. They're not coming back down. Why are they not coming back down? There we go. Okay, gotta be careful with this. Alright, that's close enough. Alright, there we go. And we're steering now with the rudder pedals. Very fine adjustments to keep this thing on the center line or close to it. The EPRs will change as you accelerate, so you set them and then don't pay attention to them until we're ready to change power.
80 knots.
There's 80 knots. Release the pressure on the yoke. I'm really glad I held the power. There's V1. Rotate smoothly on the rotation. Don't want to tail strike. Wind's pushing us off to the side a little bit, that's okay. Gear up. And then we're going to pitch for about 15 degrees for the climb out. We're past V2 plus 10, so that's good. It's a little bit windy with these storms right here. Let's get a nice little lag spike there. Can trim a little bit to kind of make that a little more stable. And there is 1,000 feet, so we're going to lower the nose. And we're above 160, so we'll go ahead and bring in flaps to 5. And I'm also going to start turning toward Craig, and we're going to maneuver this so we just know we're on a 5 basically toward it. There's 190, flaps to 2. I'm changing my Eeper bug to, oh, I can't go below where the needles are. That's interesting, okay. And there's 200, flap 0. All right, so now we're going to go ahead and pull the engines down to about 1.8 Eeper. Alright, we're flying to the Craig VOR, and we're going to fly outbound on the Craig VOR, according to this, approximately 283. This one doesn't have to be perfect, it's just a general to find the Seminole VORs, so as we get close, we're looking for this right now. By the way, right now, if you're watching this before the first update, these miles are in statute miles, not in nautical miles, so you want to be aware of that. That will throw you off a little bit. Need to keep pushing the nose down here so we can get up to toward 250 knots. A little rain on the windshield there. And I'm going to start turning, and we're going to set this to 283 so we can intercept that outbound heading. And I'll show you in a minute here. I'll get the autopilot on here in a second and show you how the INS can be very helpful with this in finding your course. It's a very hands-on airplane. There's not a lot of automation. We're going to turn the gear handle to off. Once we get on this outbound, I'm going to hit the autopilot. We'll go and deal with the engineers panel, which we should be intercepting this track in a moment. There it comes. Now, the reason why it's very, very awesome that we can back up the radio nav with the INS. Now, you can fly just with the INS. I mean, that's totally fine. I just find it more fun to be doing the VOR stuff, and it's good practice, honestly, to get used to doing the VOR stuff, to remember how to do that. So I personally love it. I'm gonna get right on that needle. So you can see now we're lined up with the course. We're flying out, the arrow's pointing down, so we know we're flying outbound. I feel like my thing keeps on the steering. That's just me. Okay. I'm going to try and lower the nose here to get us into the 250 knot range. Actually, we want to lower it even further because we're below 10, or above 10 rather. So we're going to turn the landing lights and taxi lights off. And the runway turn-off lights off. I'm going to go ahead and engage the autopilot. I'm going to show you what this does. So autopilot engage. We're going to do Alt-Select And we're going to do, I don't know why that thing freaked that out. We're also going to go into VOR loc, so it's going to track that VOR. And we're going to go into, we're in vertical speed right now. So so you can move this wheel down to change your pitch down, which is what we're going to do. I also have it mapped on my Bravo, so I can run this down and keep a good eye on the vertical speed indicator. And we're going to run this down to about just under 1,000 feet per minute, so we can accelerate up toward 300. Now, something that should be working that isn't is this speed bug right here. This would power the slow fast indicator on the ADI, but it is not working at the moment. So that little bug should jump up there to show we're fast once I set that up to 300 like that. So we could use that to kind of fine tune our speed reference, but it's not working right now. So that's another thing that's kind of bugged out. So I want to move the bug over there just for my sake. But once we get to 300, then we can switch this over to IAS hold, and it will climb to this altitude we have set here using the current power we have in and holding that to hold that airspeed. It'll pitch for speed. And we're almost there. There's 300, so we're going to go IAS hold, and now it's going to pitch for speed. While that's happening, we're going to come back here to the Flight Engineers panel. And we need to, first of all, close these cooling doors to at least half, because we're above 10,000. And we're going to switch the fuel tanks. They're all feeding the entire manifold, so we're going to turn off the boost pumps on tanks 1 and 2 because I just want to feed out of the center tank until the center tank gets down to just under 11,000 pounds. We'll be right there. Once that happens, then we'll switch tanks to engine and start feeding out of everything. But until then, that can go. You see how this guy snapped back to normal? It does that after we lift off, so we didn't have to touch that again. We're above 10,000 feet and we're clean, so we can go ahead and turn off one of the B pumps. We turn off the other one that we had on the ground. That's my method. So we just alternate back and forth. And so that B pump goes off. Packs are on. We can hit the cutoff off now because you can do this anytime after 800 feet, which the engineer would do almost right away, but since we're running this ourselves, everything else looks good over here. This is what I was telling you, the air valve mix temp goes all the way down to 0, which is unrealistic, so I don't know what's up with that. That's probably the pneumatic system that needs to get fixed. All right, we're coming up on 17, which means we're about to, we're coming up on 18, so we're about to go to transition altitude, which means we're going to set standard on all of these guys. So as we pass 18,000 feet, we're going to change these to 2992, 2992, and 2992. All right, you can also see that on our RMI, we're picking up the Seminole VOR now. So what we can do, this is how I would recommend you change over on VORs. So we're going to use our heading bug, and we're going to set our heading bug to where our current heading is, not aligned with the needle because the aircraft is compensating for the wind. So we want to fly the way the autopilot is compensating currently. So we set it with our current heading, and then we're going to come down here. We're going to put this back to roll mode and heading hold. So now we're in heading. Now we can switch to the Seminole VOR. See how it moved over? And we're going to center up, because again, this course doesn't matter. We're just going to center up the needle. So we're flying direct to the station. And then we're going to come back down here and put this back into VOR low mode. And the autopilot's going to latch on, and it's going to compensate for the wind and fly us there. And now you can see our distance to go is showing 128 statute miles, not nautical miles, which is unrealistic, but that's fine. This will be fixed eventually. There's actually a patch, supposedly, that you can install somehow on the Discord. But someone was saying it was showing zeros, but it was working for other people. So I don't know if that works yet or not. I haven't tried it. But this is showing nautical miles. This is showing statute miles. So we are flying from Craig to the Seminole VOR. So we need to update this guy to be showing the correct set of waypoints. So we're going to waypoint change 1 to 2, insert. So you can see 107, this says 123, and that's the difference between nautical miles and statute miles. So they're both correct. This is supposed to be reading nautical miles. That's just a goof. Someone missed that in the code, so they'll fix that. I'm also going to say number 2, because we're tracking to waypoint 2. This is going to help me remember, even though we see 1 and 2 right there. So that's distance and time. Now, what's kind of cool about this is we can come over here to cross-track, and we can see that this says we are 3.1 miles to the right, or sorry, yeah, I think that's 3.1 miles. 3.1 miles to the right of course. Now, this is the course, the imaginary line that the CIVA INS has drawn between Craig and Seminole, which ideally we should be flying. But it's not a big deal. On an airway, this is a big deal, and we want to stay within a nautical mile of the airway if we can. And this will help us do that, so we can kind of keep an eye on that and see. But if we want to see about how we can correct that, now what we can do is we can look down here and see, this is kind of cool. So desired track, so 276 is our desired track. That's the angle, that's the heading we want to fly from Craig to Seminole. So what are we actually doing? Well, you can look over here, but this is technically a magnetic heading. This is based on true north. Now, in this part of the world, it's actually not that far off. It's only like a 4 or 5 degree magnetic variation in Florida, so it's not too bad. But you can see right now we're currently tracking, it says 272, and there's 27. So we're clearly like a 27, we're tracking right now at like 276 or so. But that's our heading. Our track is probably it looks like it's closer to, we're doing about 270 on magnetic, and it's got us at 273 basically true. So it's pretty dang close. But we can see, we can compare that to what it wants us to do, and then we could make the adjustment on here and fly it accordingly. And we might make some adjustments on that as we go. So it's pretty cool. So you have some cool tools if you can understand how to use this and see yourself in space and understand how that goes. It's very, very helpful. So I'm going to leave this on distance. Normally I keep this on distance so I can see realistically how far I am, because this doesn't help me. But so now that we're tracking the second VOR, we need to do our job over here and set up the next one. But before we do that, we're going to slow down to 290 because we passed 20,000 feet. So I'm going to switch this back into vertical speed mode, and I'm going to manually move the vertical speed up. So we're gonna bleed off 10 knots of speed and then re-engage IIS hold. And the idea behind that is that it's a better climb performance at 290 at these altitudes in this plane than 300. It's not a huge difference, but it is better apparently. So I just want to wait for that to drop down to about 290. Once I'm satisfied with where it lands, which is about there, I'm going to go back to IIS hold. IAS stands for Indicated Airspeed Hold. And so it's indicated airspeed, means it's based on pressure and ram pressure. And so it becomes less and less accurate the higher up you go because the air gets thinner. And that's why we transition over to Mach. I'm told the Mach hold isn't working right now. So we're just going to hold airspeed, and we can reference it to the Mach meter on the outside here, and it's fine. We're going to be manually adjusting our throttles anyway, so it really doesn't matter. We also crossed above 20,000 feet, so we need to go ahead and close the cooling doors in the PAX 2 3/4 as well. Again, I'm going to be a little behind the curve here because I'm explaining all this stuff to you. I'm not just doing it. When I'm just doing it, I can just do it quickly, but when it comes with explanation, it takes a bit longer. All right, so now VORs. We want to switch over the number 2 to the next one, which is the Crest View, I think. What is it? CEW, yeah. And we can see we're actually, wow, that's a high altitude one, high power one. We're already picking it up. We're showing 225 statute miles away, which means we're probably like 205, 200 nautical miles away, something like that. So that's pretty good. A lot of VORs are really low power in Microsoft Flight Sim, and there's no margin for error. So normally if it was rated at 40 miles, you'd still pick it up at almost double that, but it would be not certified for that, but you'd get signal faintly, and it would get stronger as you got closer. In Microsoft, if it's rated for 40, it cuts off at 40, which is unrealistic. That's not how radio waves work. But that's how they had to simulate it, and that's how they chose to simulate it, which is unfortunate. I wish they would have, like, added like 20 miles or something, at least as like a buffer to simulate the fact that it would really go further, but they didn't. So that's what we're stuck with. So now that we switched that over to the next one, what we want to do here is put the that guy in our standby, because that's the one we're going to be switching to next. So 11590 comes over here. Make sure you're putting it in the one that's not lit up blue. So 11590 goes over here. And now in this one, so these aren't in a typical like a 737, 757, all those. You have, this is always the primary frequency, and you swap them with a standby. In this, it doesn't matter. It's whatever this switch is looking at. So you have these little lights to tell you which one is the current prime frequency and which one is the standby. So now in the what is now the standby over here, we're going to put the fourth VOR that we're going to track, and that is going to be the Macomb VOR, which is 116.7. So 116.7 goes there, and now that's all ready to go. So we still have a good 61 miles to go before we reach the Seminole VOR. You can see we're only 1.5 miles to the right, of course, now. So it's gotten better as we've kind of honed in on it. And the closer we get to the station, the closer this number will get anyway, because we're triangulating, you know, toward it. We're coming to that point in space. So we're naturally getting closer to our preferred track, since we're generally in the ballpark. But you'll see how much more accurate this is in a little bit. Now, the other thing to look at is on this desired track, which also has the status. You notice our status is no longer 0, it's 2. So these things drift. It's basically a spinning gyro, or series of gyros that are resistant to change in space once they're spun up. And so they can use that plus some accelerometers to sense whenever you move the airplane forward, backward, left to right, up, down in space. So you can basically, as long as you tell the INS where it is in space, if those gyros are spun up, it can then calculate where it's gone using the acceleration and time, which is really quite cool that they were able to do this back in the 60s. We have ring laser gyros now that do the same thing, and then we back that up with GPS satellites, but we're still essentially using gyros of some kind, whether they be physical spinning gyros or the more common in aircraft nowadays, the ring laser gyros. Mentor Pilot did a cool video explaining how these things work, and it's fascinating. The coolest thing about that was the ring laser gyros are so accurate that they can sense the difference of they can sense the Earth's rotation, and because the rotation speed is slightly different as you go away from the equator, because the Earth is widest at the equator on its rotational axis. As you go north, that rotation gets basically smaller. It's like the spokes of a wheel. You know, as you go in toward the wheel, you're rotating faster the closer you get to the center of it. You're rotating slower the closer you get into it, because the outside of the wheel has to go the same amount of distance, whereas the inside doesn't go nearly as much. The same principle. And so as you go north or south from the equator, that rotation speed slows down. And so the gyro can actually tell fairly accurately what line of latitude it's on based on, I mean, it can't tell north or south, but it can tell you what line of latitude from the equator you're on based on the rotation of the Earth once it's spun up. And also and he makes a kind of snide comment that, by the way, doesn't work in a flat Earth. So, FYI. So, sorry all you flat Earth people, it kind of debunks you. But it's really cool that they're so accurate they can do that. So, but they do drift over time because of, you know, different forces acting on them and gravity and stuff like that. So, there's a way to update these as we go, and when we get a little further on the flight, I'll show you how to do that. At this point, we're basically... that's basically all you need to know at this point. I'm going to bring you back in a little bit, and I'll show you how to do the DME updating for the INS. But at this point, it's just changeover, station to station. We've reached our cruising altitude, which means we're going to close the cooling doors. Whoops, opening them. Close the cooling doors. And again, you could monitor the temperature in the cabin if this was working right. It's not. You could monitor the fuel temperature if this was... See, this isn't really moved. I don't think this is working right either. So there's some things, like I said, there's some system bugs that kind of take away from the total immersion of it. As of right now, they're fixing. It's not like it's going to stay this way, but the airplane still remains very flyable, and it's a joy to fly. So yeah, don't let that stop you from picking the bird up. I say get it anyway. But yeah, everything's... You just kind of keep an eye on the engineer's instruments, keep an eye on your oil temperatures and pressures, making sure nothing is going wrong, making note of the generator drive, the CSD drive oil temperatures and the rise. The outer scale shows the rise, the outer scale shows the in. The idea is one is measuring the temperature of the oil coming into the CSD, and the other one is measuring the rise in temperature after it goes through the CSD. So you can verify the CSD is operating by saying, hey, there's an oil of a said temperature coming in, and when it goes out, it's hotter. And that increase in heat should be within a certain range to tell you that the CSD is healthy. Obviously, if it's way off the scale, that's not good. And the fact that the oil is coming in at a certain temperature, you want it to come in at a certain temperature, not be too cold, because then you wonder what's going wrong. But also, two, if it comes in too hot, then means the cooler is not doing its job. So you got two different things that are going to tell what's happening. So you change this from in to rise, and you can see a difference. And so once they kind of warm up the scale there, you can switch between them quite quickly, which is kind of cool. Until you do it the first time, it takes a while for the other one to check on. It's kind of cool. So... All right, and I think that's it, what we're going to do for now. Actually, we're coming up on this wait, but we'll change over. I'll show you this, because now we'll be actually on an airway. We weren't on an airway before. We will now be on... Actually, will we be on an airway? Oh, no, I'm in IFR low. Oh, maybe not. Maybe not yet. Okay, we're actually not in an airway yet. Not until... I could have sworn this was an airway one, but I guess not. Huh. Yeah, no, it's not. I think I meant to go up to Mariana, but I didn't. That's fine. Doesn't matter. I'll show you when we get to an airway one then. So when we come back, when I bring you back, we'll go over DME updating, and we'll go over when we change over, when we're actually on an airway, and I'll show you the difference. Because right now I'm kind of guessing with our numbers here. So, well, actually, let's see. Let's do it this way. So our desired... let's do this. We're going to say, just in time, we're 5 miles from this, so let's set our heading appropriately. And then we're going to go over here and set it into heading select. And we're going to change this. Waypoint change 2 to 3. Insert. What is the desired track? It is 278. What is our current track? It is 273. What did I say, 278? Yeah. So that's a difference of 5 from where we are now. So what we're going to do is we're going to move this from where it is now 5 degrees over. 1, 2, 3, 4, 5. Are we able to switch yet? Yes, we are. So we're going to go ahead and switch this. And now I'm going to maneuver the heading to bring that needle in. And then we'll re-engage VOR, and we'll see how close on the INS system we are. Again, you have to kind of use where you currently are and where you want to be, because you're looking at magnetic here, you're looking at true here, and then all of these are being affected by winds. So you kind of have to use what you know and what you don't know together to make a complete picture. But I want that needle centered before I look at this again and make a judgment call on whether or not I've done what I need to do. Although I don't think I've done it right based on what I'm seeing on my Navigraph chart. because I don't think we'd be flying that much compensation. So let's go ahead and go to Navloc, and then we'll see where it puts us, and we'll see what it does. So right now it is set in, oh, you know what? I wonder if I went to heading. Maybe that's why my numbers were wrong. I wonder if I didn't scale it all the way around. I thought I was in track. Maybe I was. I don't know. So yes, the track is correcting a little bit. If we go to cross track, though, we can see we're 2.7 miles to the left, so we're definitely out of sorts a little bit, and I can tell you that by looking at my Navigraph chart over here. So what that tells me is I did this too far, so I could correct this a little bit by putting this over another, like we'll change this by 2 degrees. Or sorry, not that direction, 2 degrees. We're going to go the other way. We'll go back 274. That'll force the airplane to fly to the right, and we'll watch this sync up. So we could actually kind of watch this and then see where it steadies our track off and see if we get into the into the ballpark. Because basically, if this reads 0 and our needle is aligned, then we're on the right track. If this reads 0 and our needle still shows us we have to correct and deviate, then we're not on the right track for the plan. Basically, the line between the 2 points. So I'm using this to prove this, because what Navigraph gives me is 284, and you can see right now I'm pretty close, and we're at 274. And the reason for that is because of magnetic variation things, and it's such a long way and all this stuff. So it gets complicated when you start thinking about the difference between true and magnetic, and the differences between one station can be one magnetic variation and the other station can be another. It starts making your head spin. And so you can find when you're flying VORs, flying needles, that if you look on Navigraph, all of a sudden your airplane is like to the left or right of course by a few miles, and you're going, what the heck? I'm on the course. Why is that not lining up? And that's why. It's because of those issues. So we can get this a lot closer with this. So you can see that line's coming in. We're probably still off a little bit. Probably off by 1. But let's see. I'm going to wait till it goes to 0, and then we're going to do that. And then we'll cut the video here, and I'll have you guys catch up with me when we get a little further along in the course. Also, I'm realizing, just noticing my my speed is getting a little less spicy up there, so I'm going to pull the throttles back just ever so slightly. I want to keep that closer to Mach 0.8 or so. Or Mach 0.82. Maybe we'll do Mach 0.82. It's a long flight. Might as well. Alright, there we're 0.2 left, of course. I think we're going to bump at 1. Yeah, we're going to bump at 1. So it's going to be... Oh, well, it's like right... I don't know. It's kind of like in between 2 degrees. It's like it wants to be at a halfway point, so we're not going to be perfect, but we'll be something. So I'm going to go 275. We'll try that and see what happens. But we're in the ballpark. Distance and time, 74 miles to this one. And we need to see about putting our next one on here. So put that number 2. And you notice this goes to 0. So we're not picking up the next VOR yet. So when that happens, we fly outbound on the course that we need. And I'll talk about this here for a second, because this will help you. Oh, this one's not... Oh, man, we're not picking up the airways until we get to MCB. Man, when I did this, I could have sworn I was looking at actual jet airways at the time. Oh, I'm back in low IFR. Why do I keep switching that? There we go. Okay, yes, we will be on a on an airway. So, and it's hard to see. I talked to Navigraph about changing this when I was at Expo, so hopefully they do. But so we're going to be coming into Crest View here, and then we're flying out in this airway. And you might be able to make out right there. It's hard, especially because it's got the purple over it. you can kind of see, but these numbers don't get bigger as you zoom in, which is what I told them they need to fix. But you can see that airway maybe is labeled 277. So our outbound, we're going to fly that as 277, and that is the correct radial. It's a published radial, compensated for by magnetic variation, all that stuff. If you look over here, it says 277. Navigraph says it should be 284. So there's a difference. So that's what I'm talking about. But when you get over here to Macomb, you'll notice that this is 095. Well, the reciprocal of 277 is not 095. So as you fly to the station, it changes because its magnetic variation is different. So around the halfway point, you'll find you'll be changing this to match the station's correct mode of operation. All right, guys, we're coming back in. We just passed over Fort Worth. You can kind of see it in the background there, which means we just passed over the Ranger VOR. And it is not only time to start talking about going tank to engine on the fuel, but it's also time to step climb. According to our flight plan at the Ranger VOR, we need to step up to flight level 320, and I've actually passed it. I would have wanted to cross it at 320, but I was busy trying to find something and missed it. So we're going to do it now. So let's go ahead and get back in the flight deck here. So to do the step climb, we need to do a couple things. We need to tell the pressurization panel we're going to go up. So we're going to set our new flight altitude to 320. We need to change the cabin altitude for 320, so that is going to be 4.4. We were at 3.6. We're now going to go 4.4 right there. And so we're going to step the cabin altitude up. And you want to be careful how you do this so it doesn't jump on you funny. So, whoops. 4, there we go. 4.4. And I'm going to go ahead and switch this to standby and then switch it back because I think it kind of needs a little jolt at some points, but we'll see. Now we're going to go ahead and start the step climb. So to do that, we're going to go ahead and set 320 here. Arm the alt select and then go IS hold. And we're going to add in a little bit of power. Not too terribly much. Just a little. But we got to get enough to make sure that needle can climb. We don't have to climb fast. We just climb up ever so slightly gently. While that's happening, I'll update you on our navigation situation. Why did this open? Go away. We're currently tracking outbound the Ranger VOR toward Abilene, and the inbound course for Abilene is going to be 69, and I've got Abilene tuned up on the number 2 11370, and we are picking it up. So we're going to go ahead and switch over to Abilene. So it's sorry, the outbound course is 69, which means the reciprocal of that, and so 70. We're at 255 now, so I think that's going to be 259 if I'm not mistaken. It's almost going to be 70. No, it's going to be 249. Yeah, 249. So 249. Yeah. So we're going to set our heading bug. And then we're going to switch over, roll, heading hold, and then switch the station to Abilene, set 249, and re-engage localizer. And that will steer us into Abilene. Now we're direct to Abilene. And then the next VOR after that is going to be the... let's see, the Chisholm VOR at Roswell, New Mexico, 116.1. So we need to set that into our next standby, 116.1. And we'll set 116.1 over here as the primary on the secondary. And then the next VOR after that will be Truth and Consequences, 112.7. So then we got Truth and Consequences. Now remember, Truth and Consequences is our last INS waypoint, and we're at 6 to 7 right now. So we can start adding in some waypoints on the back end. So I'm going to go ahead and do that. But once I want to make sure we verify our step climb here first. I'm going to give it a little bit more gas. Actually, what I'm going to do here is I'm going to go back to vertical speed, and I'm going to increase the vertical speed. We're going to drop a little bit of speed. We're going to go back down to 300, or closer to Mach 0.8. We're getting kind of fast. We're getting close to that barber pole. So I'm going to trade some airspeed for climb here. And then we probably are ready to go tank to engine as well. We'll double check that in just a second. You kind of start to feel it buffet a little bit, and that's what's telling me we're a little bit fast. We'll back off the power a little bit since we're coming up to the altitude. New cruise altitude of 320. Remember, higher altitudes allow you to burn a little bit less fuel over time. The trade-off can be, though, that there might be higher winds up at altitude. So if it's usually the navigation software like Simbri figures that out for you and decides, is it worth it to go up to save the fuel versus the higher headwinds. Of course, if we're going eastbound, it would be higher tailwinds, so it would be all positives for the most part, and it would just be about our total weight and whether or not it's possible for us to get up there, or efficient, the amount of fuel we have to burn to get up that high. And so generally speaking, as we get lighter, we can go up higher, and if air traffic control will cooperate with that, then we can burn less fuel. And speaking of fuel, I have a confession to make here in a second. All right, look at that. So we're right at 11,000 pounds. These are just a little shy of 11. Actually, that one's showing right about 10 now. That one's changed a little bit. Why is that one starting to burn? It shouldn't be. Actually, I wonder if it does once they start to get equal, if they start to kind of equal out a little bit. But we're in the ballpark, so we're going to go ahead and turn our boost pumps on, and we're going to switch tank to engine. So now the left tank is only feeding the left engine, number 1 engine. The right tank is only feeding the number 3 engine, and the center tank is now only feeding the number 2. Up until now, the center tank has been feeding all 3, and these guys just been sitting idle. So we're now tank to engine. It will stay that way until we land. And we're holding speed pretty well. We're at the new altitude. Let's see, is it made an adjustment on our cabin altitude? Cabin altitude actually is at 6,000 feet. So this controller isn't actually doing its job. Like I said, the pneumatic system has some issues. This should be running up higher to this. This should be down lower. But we're doing our job as we're supposed to. Kind of want to see if I put it in standby what it does. I can also put it in manual. And if I open... Oh, good lord. Alright, let's not ever do that again. Yeah, it would not change that fast. Yeah, this system's all screwy. I think this should get us back. Yeah, okay. Pressurization controller doesn't work. At least not like it's supposed to. That's terrifying. Yeah. The outflow, slowly opening the outflow valve does not like immediately depressurize the airplane or immediately pressurize the airplane, so that's incorrect. Alright, well you can see we're holding speed. I'm going to back it off just a scooch. Again, the idea, generally speaking, you're probably going to be cruising right around 3,000 pounds an hour on each engine, which is what we are. So that is a nice little check for your cruise power. More so than your EPers or your N1s. That's usually what you're going to be watching. And, oh yeah, the fuel that I have to confess to you. Okay, so the sim brief, and this is the profile from FSS, has a glaring error that I just discovered while I was doing some fuel calcs while we were in flight. Now, granted, I should have double-checked this on the ground, so, you know, my bad. But still, this is kind of bad. So, if you look at the fuel gauges, you'll notice they go at a maximum scale. This is like 12,000 pounds. This is about 32,000 pounds, another 12,000 pounds. So, given all of that, that is 24 plus 32 is about 50, what is that, 54? 24, 3 is 5, no. 4 and 2 is 6. So it should be about 56,000 pounds. I don't do math on Sundays. Okay. 56,000 pounds. But, however, when you go over into the booklet over here, our max, and these are maxed out, by the way. This is from when we loaded earlier. Our max, it's close to that. It's 11,926, but 351. So we can't quite get even to 31. So it's close to that. So we're looking closer to 55, 54 and change, somewhere in there. However, on the sim brief profile for the FSS, which now I'll say I did edit it, but not any of this, because there was their weights and their maxes, so I didn't touch that. If you look over here, the max fuel capacity says 70,920. Uh-oh. According to this airplane, I can't take anywhere near that. I'm like 20,000 pounds shy. So this thing, when it was doing my calculations, it was putting me pretty much close to maximum takeoff weight, and I should have my ears should have perked up when I saw my takeoff weight was about 81,000, I'm sorry, yeah, 181 as opposed to the 191, or 184 as opposed to 191 or something like that. We were a lot further from maximum takeoff weight than I thought we were supposed to be. Because what SimBrief ended up telling us was that we should have loaded 61,478 pounds of fuel. Well, as we just saw, that's physically impossible. We can take a maximum of like 55,000 pounds. So we're about 6,000 pounds shy of our fuel load. Now, I've done the calculations, and because that number included alternate fuel and reserve fuel and contingency fuel, we should be okay. The total trip fuel for this route was slated to be 48,330 pounds. We took about 5,440. So we're about 6,000 pounds more than trip, and that and it counted reserve fuel was 6,000 pounds, and then plus another 4,000 for the alternate and another 2,500 for the contingency. So assuming that we don't need to go around and we don't need to divert and all that stuff, we should be okay. Legally, we are in trouble, but this is a sim. So something to be aware of, you might want to go in and edit the profile. I'm going to make a note of that to them and let them know that either their profile is wrong or their max fuel capacity in the actual plane is wrong. I don't know which is which, because I haven't done any research to see what the typical fuel capacities were for 727s. I'm wondering if there's a difference for the freighter versus the passenger, and they picked one instead of the other or something. I don't know. But yeah, I don't know. The 70 does kind of sound high for a 727, so my guess is closer to 55 is probably correct, but I don't know. And I think we just flew through Abilene. Yeah, we did. Bad pilot is bad. I'm not paying attention. All right, so after Abilene, we should go... let's see, where did my Abilene go? 273, is that what I'm looking at here? Yeah, 273. Okay, so we're going to go ahead and... Oops, that's not what I want. Make sure my heading bug is centered. Heading. And then we want 273 off of Abilene. And if we go over here and waypoint change 7 to 8 and insert, we can go over here to our cross-track error and we can see we're 8.4 miles left of our course line. So we're going to dodge this over and you'll see that center up here as we get on course. Now we're using that to confirm. I'm using that basically because I can... This only tells me so much. I could be like way off course and I could be wondering what the heck. And I can kind of tell based on the RMI needle over here, because this is just pointing to the station from my relative. So this bug up here is me, my angle, and I can tell based on that where the station is relative to me. And obviously I want it to match this line. So the further I fly this way, the further off course I am, the more this is going to deflect up away from me and make it close to horizontal. I want this eventually to be directly behind me. So I can use that to kind of see in space. This just kind of helps give me another idea of, oh, I'm 7 miles off the course line, or I'm 20 miles off the course line. It helps. So this is where having the INS is the backup. I'm not flying off the INS. Part of the reason is because it's kind of fun to do all this and gives me more stuff to do. And I can use the INS as backup. But if I ever get to a point where I'm like, I'm too far from a station and I'm not close enough to a station where I'm not picking up either of them, I can just immediately switch over to INS navigation and I don't have to use Dead Reckoning. If I didn't have the INS, I'd have to use Dead Reckoning. I just have to go with the last heading I had and then hope I pick up the station soon. And any drift in the meantime, I just have no idea of until we pick up the station again, which can be dangerous. And if the stations are too far apart from reception of each other, you can kind of get yourself in trouble there. So it's nice having the INS. So we are navigating outside. We're leaving. We're going away from Abilene. We're headed toward Chisholm, which is basically Roswell, New Mexico. And then we have a short little jaunt. I mean, I say short compared to this one. This is a 245-mile leg. We have a 133-mile leg to Truth and Consequences, which is our final VOR of the currently programmed. So the nice thing is, as soon as I get on course here, you can see that coming in now, 3.6. Once that hits 3, I'm going to dodge this back over, and it'll start, because it turns kind of slow at in flight here. So there's 3.1, 3.0. Okay, here we go. So I'm going to bring this back over. I'm going to get it turning. And I don't like to engage the VOR until the needle is pretty close. And the reason for that is sometimes the autopilot, especially in older aircraft like this, can really overcompensate trying to capture the VOR if you're too far off course. So you make for a much smoother ride if you can kind of anticipate and read the needles yourself. And so I'm going to kind of bring this back a little bit because I don't want it to get it too far. And I know from experience that it's going to cheat this side of it due to the wind direction. And so if we go too far over there, like 2.1, you can see if that goes to 2.2, then we're yeah, so it's still coming in. That's good. Slowly but surely. I'll cheat it out a little bit. I think at about 1.5, I'll go ahead and engage. We're legal now. We're within 2 miles. I believe it's 2 miles that you can be within, I think. Don't quote me on that. All right, there we go. So we'll go VOR lock, and it'll, so yeah, it's hardly moving. You can barely, so we got it pretty dang good. It's going to be just making some fine adjustments to bring us in on it. All right, so with that done, we can now, we've got a little ways to go. I can look at our time and distance here to our next waypoint. Yes, we got 189 miles before we hit our final waypoint of Truth and Consequence, or sorry, of Chisholm, and then we have one more waypoint after that. So I want to program in some more waypoints, and I can do that while we're still, well, keeping those other ones. So to do that, we're going to come down here, and we're going to go to waypoint, and we're going to start with number 1 again. But now we're going to put in, we're going to override this and put in new waypoints. We're still flying 7 to 8, but we're going to fly new waypoints. So the next one we haven't done yet is the Phoenix VOR. And so I'm going to go over to my my list here that I've shown you previously, and we're going to put in the Phoenix one. So this is a north 33260. So I'm going to say north 33260, insert west 11158.2. 11158.2, insert. So now we have a new number 1, and that's Phoenix. Number 2 is going to be BXK, which I can't remember what the name of the VOR is, but it's outside of Phoenix. It's like Buckeye, I think, actually. North 33272. North 33272, insert west 11249.5. 11249.5, insert. Number 3 is now going to be COFA, which is not a VOR. It's actually a RNAV point in space. So this one we really want to make sure we have in there. Again, I can find this theoretically with the VORs because it's on a jetway, a jet airway, but yeah, it's better to do this. North 33278. 33278, insert west is going to be 11320.9. 11320.9, insert. Number 4 is going to be Blythe, north 33358, insert west 11445.7. 11445.7, insert. Number 5, Palmdale, north 34379. 34379, insert west 118.038. 118.038, insert. Lando, another RNAV point. Now notice this is waypoint 6. We are stopping here because we're going from 7. I do not want to change any of the numbers that are in this box. So this is our last waypoint. We're stopping at Lando. So north 35007. 35007. Insert west 118.370. 118.370. Insert. All right, so we stop at 6. Lando is as far as we go. We actually only have 2 more waypoints left, actually 3. We want to program in Avenal, which is the one after Lando. We want to program in, and that's the beginning of the star. And then normally after the star, we would just program in the airport, but because of the situation into Oakland, we're going to program in the final approach fix too. And that I think is going to be, let's see, oh, it's not listed here because it's on the approach section. So it's, I can't remember the name of the waypoint. I'll have to look it up. And then we'll put the airport in as well. And that's, we always put the airport in as a way of having a direct to the airport in case ATC was to give us a, hey, just fly direct to the airport and then we'll give you vectors to the ILS or something. Again, we're not on ATC today, so that's not going to happen. But it's always good to be prepared and to get in a good habit. So I think I mentioned I was going to show you how to update the DME on this thing. I tried doing it through the instructions that they have, and it's not doing it. So I feel like there's this. It's been so long since I've used an INS on the Fila 7.4, and I know there was a step that was needed in order to like tell the unit to start the update, and that step is not in the instructions from from FSS. I did see someone on Discord say they had done it and were successful with it, so I put out feelers to say, hey, what am I missing? Because I'm trying to like go around YouTube videos and kind of say like, okay, what was the step on the INS? Because I read the instructions on a CIVA manual I have, and it wasn't exactly clear, and it wasn't necessarily for the 727, and so depending on how they implemented it, might be different. So I don't know if I'm going to be able to tell you. I may have to do a supplemental video on the CIVA just to tell you how to do that. Or I may put it in the comments and say, here's your method. But I don't think we're going to get to show how to update it in this video, unfortunately. I was hoping it would work, but alas, I've been foiled. So there you go. All right, we're going to, I'll catch up with you when we get to the approach section. At this point, everything else is going to be what you've seen already. I don't think, do we have another step climb, or is it just the one? I think it's just the one. No, we do have one more at Phoenix. Yeah, we're going to step up to 3-4 at Phoenix. So we have one more step climb we're going to do, and I don't think I need to bring you back in for that. We'll just do it, and I'll bring you back around Avenal for the approach into Oakland. This has been a fun flight. It doesn't feel like it's been as long as it has been because we're just constantly doing stuff, constantly updating and switching VORs and changing frequencies, and it keeps you busy. That's what's cool about this plane. It's a fun one to do long hauls like this, and know you're navigating without a magenta line. So, all right, we will see you back at the beginning of the descent. All right, welcome back to the flight. We are at our ending point here. We're coming up the Central Valley right now. You can see the Pacific Ocean out here. It's been a long flight, but it's gone by pretty fast. Again, thanks to having to constantly be changing over VORs and waypoints and INSs and stuff. And I tried a few more things with the INS. I still can't get it to update, so I'm going to do some more research on that and get back to you guys on that one. But it's not a big deal. It doesn't drift as much as it's supposed to, really. And from what I understand anyway at this point, so hopefully we'll get some more clarity on the procedure. Anyway, enough said on that. We're going to look at our arrival information, and again, we have to choose an arrival that is a non-RNAV arrival because we can't use the INS for terminal navigation. And there's only one RNAV into Oakland, or sorry, one non-RNAV into Oakland, and that is the Panoche 6, and so that's what we're going to do. So if we take a look at that chart over here, you can see we're going to be coming in at Avenal and then going up to Panoche. These expecs, we would normally treat them as not hard altitudes until ATC told us otherwise, but especially in a jet like this, we want to plan for those because we don't have an FMC to tell us when our top of descent is, and so we need to kind of do that calculation ourselves. And since we don't have ATC, we're going to treat them as hard altitudes to help us descend and get down. So we have a 240 hard altitude. We're going to treat it as such at Panoche. And then at board, we have a 250 knot, 10,000 speed restriction, 10,000 foot altitude restriction, 8,000 if we were a turboprop, but we're not. And that's at board. And then on down from there, we can go the rest of the way. Now, you'll notice there's a whole bunch of points here that are not VORs, but we can find them all based on triangulation from the various VORs. From Panoche VOR, we know when we cross Cairn at 35.5 DME on that radial, and we can cross-reference it from the Modesto VOR, the 191 radial there, at 32.4 DME. Same thing with this one, 215 DME for the board waypoint, 227, not DME, but radial, 227 radial for Bushy, and so on and so forth. All the way to Sunol, which is going to be cross-referenced off the San Jose VOR. So we're still going to be switching a bunch of VORs to try and maintain our course and know where we are on this point here so we can descend all the way down. We're at 34,000 feet. We did our final step climb over at Phoenix. So we went up to 34, and we're going to be going down to 24, so we got to lose 10,000. So there's a couple different ways you can do this in this aircraft. If you want, in the PFB, you can look here under flight, and it will give you a descent calculation options, which you can utilize. But I'm going to teach you how to do it without that. But if you want to utilize that, go right ahead. There's no shame in that. We're coming up on Avenal right now. I'm just going to make a note here. We got to fly outbound on the 313 here. So 1 second, let me make sure this is primed and ready to go. Switch over to heading. And then I'm going to switch this over to 313. And I'm watching this as we get close here. We're going to start turning. In fact, I'm going to start turning now, since we got a bit of a turn on this anyway. Remember, this is statute miles as of right now. This is nautical miles, but it's also not based on slant range. So this, when this says 0, we're right over it. When this says like 6, we're also right over it. It's very confusing. And it's more confusing because I'm used to nautical miles, which is what it should be. So it's gone away. We're in the cone of confusion. There's back. And that's the best option right there, is where we're actually on this side of it. So we're going to keep ourselves on this side of it. And as that tracks in, we're going to switch back over to Vorlock. And that will link us up. Okay, so we have to be in about 74 miles from Avenal is the Panoche VOR. And we needed to just lose 10,000 feet. So we use the rule of 3. We multiply our altitude, drop the final 2 zeros, or sorry, the 3 zeros, and just look at the first 2 numbers, 34. What's 34 minus 24? 10. What's 10 times 3? 30. So roughly 30 miles to descend 10,000 feet. Now you want to pad that a little, because oftentimes we have to lose some speed. We're also not going to be perfect on getting our descent rate right away and all that stuff. So I usually add about 10 nautical miles to that. So we're going to call it 40 nautical miles. The changeover point where we start tracking the Panoche VOR is 45 miles from the Avenal VOR, or 30 miles from the Panoche VOR. And so, since we want to start down at 40 miles, we're going to, at 55 miles from the, 35 miles from the Avenal VOR is where we're going to start our descent. And we're not going to look on this, we're going to look on this, because this will give us a more accurate reading of being 35 miles from the VOR. We're not changing this over yet, because this is going to go directly from Avenal to our final approach fix, and we don't want to do that. So, because we're not using this anymore until we get to the final. And so the last 2 waypoints in here are 8, which is the final approach fix, and 9, which is Oakland itself. So we're coming up on 20 miles off of the VOR. And we can also take a look at our fuel situation and see we're doing okay. We just a little while ago passed 4,200 in each tank, which was the fuel we should have landed with. But that's because we should have had like 6,000 additional pounds of fuel. So given that, and the fact that we still have, what are we at right now? 3.5 roughly in each tank. That's 10.5 thousand pounds left. So we've got a fairly good buffer of fuel still. So we're okay. We're not legal, but we're okay for that. All right, 26. So about 10 miles to go. We'll start down. And we want to make sure we tune up the Panoche VOR. So that's 112.6. Because we are going to track that eventually. 112.6. And we're going to put 112.6. I'm breaking my rule here because at this point I'm not doing hard changeovers anymore. I don't really care. This is going to now become a reference point for the most part. And you can see we're not even picking up the Panoche VOR yet anyway, so, but we should get it within 30 miles of it. It's probably a 40-mile range VOR, which is important to know because we're going to have to track that thing outbound 72 miles, and we're not going to be able to do it. So we're going to have to hold heading and then cross-reference our position with Modesto and San Jose, and that's going to be good enough, and so that's good to know. Thankfully, Avenal has a nice range. All right, there's 35, so we're going to go down to 24. 24, arm altitude, and we're just going to stay in vertical speed mode, And we're going to start on down, and I'm going to pull the power back a little bit. We're going to go down about 2,000 feet a minute. So you see, it took us about 5 miles to get to our 2,000 foot a minute drop even, so that's why we pad it. Plus our speed's also increasing, so we're going to pull some more power off. This will help us conserve some fuel anyway, so that's all good. When we get a little closer, we'll do this, but also in the landing section, you can bring in the weather here. Now the temperature is showing the current temperature where we're at, so that's not, obviously it's not minus 34 in Oakland in the summer. That's ridiculous. And I think the altimeter is probably set to that too, and you can't change these. They're going to make these editable, I believe, and more close to whatever your landing airport is supposed to be, I think. But we are going to be flaps 30. Our gross weight probably is around 140,000 pounds or so. It's going to be close. The main thing we want to look at is our approach speed, 133, and our VREF of 128. And if we hit that set speeds, it'll set those for us right there, so we can have those. And we'll double check those are still accurate as we get closer. As far as the descent goes, the TWA manual says you can basically descend 3,000 feet all the way to about, I think they recommend about 20,000 feet, and then they recommend closer to 290 again, 290, 280 for the last bit down, and then obviously 10,000, or sorry, 250 below 10,000. So we're going a little bit less than that right now, mainly because I don't want to overrun our spots. Changeover is right there. There's Panoche, so we're going to go ahead and switch over to heading, switch to Panoche, and that should be 30. No, it's still the same, right? That's still 313, yeah. So 313 stays, and we'll just go ahead and nav lock that. All right. So at this point, I'm going to go ahead and put this on the waypoint because this is now pointless for us. We're going to use cross-track reference to figure out where we are from now on. So the next reference point we're going to use is Modesto, 114.6. So we're going to put that in the secondary, 114.6. And we are picking up Modesto, so that's good. And what we can do is over here, the first radial crossing point is Karen, and that should be on the 191 radial. So we're going to set that to 191. And what that'll do is it'll tell us we've reached Karen when this bar crosses. 191. So we're going to keep an eye on our instruments over there. The other thing we need to do, we haven't done this in a while, is we can go ahead and open the cooling doors to 3/4. 3/4 closed, that is, not 3/4 open, 1/4 open. And we'll do that until we reach transition altitude. And then we'll go half. Alright, we're just crossing the 10 statute miles from Panoche, VOR, which means we're probably about 8 miles from the actual station, 8 nautical miles from the station. And we're about 1,000 feet, 1,500 high. So we're going to cross it pretty much right on the money, for the most part. It's not bad. Not too shabby. You don't ever use, at least the real guys didn't ever use IAS hold for descent. This was a climbing mode only. We pretty much always use vertical speed. Vertical speed or pitch hold to go down. I don't ever use pitch hold, but vertical speed is my friend. There we go. Look at that. We just flew into the cone of confusion at 100 feet above our target. And as we level off, we'll increase the power a little bit. Again, we can use that right around 3,000 pounds per minute to kind of get us in the ballpark of where we want to be. It's going to change a little bit as our altitude increases, so it'll become, we'll have to use more and more fuel as our altitude goes down, so it'll probably be closer to 35, 36 at this point. I want to kind of maintain that 300. All right, so we've flown over the Panoche VOR. The next level down is 10,000 feet. We want to be 10,000, so that's 14,000 feet we got to lose. So that's 15, 30, 45 minus 3 is 42. So about 52 miles. And we have 35, 45. We need to go down now. So we're going to just keep on dropping. So down to 10,000. Oops, stop that. 10,000 and arm that and vertical speed. And we'll kick off a little bit of power again. And actually I'm going to kick off a lot of power because I want to lose, we're going to be going down to the 250 knots thing, so we might as well try and lose some of that speed in the descent. So we're going to keep our 2,000 feet a minute. I'm going to come over here and we're going to pull the gear warning horn so it doesn't blare at me, because we're going to basically chop the throttles. And we won't touch the speed brake yet. We'll see if we can avoid using that. When we pass Modesto at 191, we've got approximately 13 miles to board, which is our 10,000 waypoint. So. This is where it gets a little busy. A little busy. Again, we're just going to keep an eye on that that guy over there. My heading bug is set, so as soon as we lose the Panoche VOR, which will probably be around 43, 44 miles is my guess. It would be 40 if this was nautical miles, but I've got to convert my head to statute miles. Maybe 45, somewhere there. The bigger the number gets, the bigger the difference. So. And then the weather for Oakland right now is showing they're landing on 28 right and 30. We're planning for 30. Winds right now are 260 to 11, gusting 26. Well, that's fun. 10 miles visibility, overcast at 100 feet. Really? Well, that's fun. Let's see if that actually is what's going on. 10 mile visibility. Okay. Hopefully not, because that's. Oh, sorry, that's 1,000 feet, not a. Okay, yeah. Not 100 feet. 1,000 feet. Overcast 1,000 feet. I was gonna say that's gonna be below minimums for us. Temperature 162.13, altimeter 299.6 as we're coming up on transition altitude here, and we're getting close to that 250 bug there, which is good. Allow us to make sure we're making our descent rate. Again, constantly checking over here, making sure nothing is funny business. The pressurization system is working, it's descending, so that's good. And I'm watching this, getting ready to lose that Panoche VOR, and we'll just continue on heading at that point. And do our best. Dead reckoning. Alright, so 299.6, we're going to set there, and there, and there. So that is set. Still this side of Karen, so we have not crossed it. I expect that's a 35 We just crossed 36 statute, so this should be coming in any minute now. And then the next point will be 215, and that'll be board. And that tells us we have 13 miles at that point. Which is right around where we should lose Pinoch, if I'm seeing this right. There it comes. So we're crossing, we got 5,000 feet to lose in 13 miles. And using the rule of 3, 5, 10, 15 in 13, so we're actually a little bit behind the curve. Well, actually not yet, because we haven't crossed it yet. We're crossing it right now. We're at 14.5 now. So we're pretty much right on profile. That's pretty good. That's pretty good, yeah. This is going to be 4,000 feet there, 4,812, and 13 miles. Man, we are right on descent path. Look at that. See, who needs a VNav? This is what is possible even without all the fancy magenta line stuff. You too can be a real pilot. All right, 215, since we're crossing that right now. So we're going to change that to 215. And this is going to tell us now when that comes in that we're crossing board and we should be at 10,250 knots. Now we're at 250 knots, so we've matched that. So all we got to do now, and there we just lost the localizer. So there's, Pinoch is gone. So we're going to go to heading, hold that heading. And we're waiting for board to come in to tell us we're there. After that, we're going to go 227 to Bushy, and we might as well go ahead and set the San Jose VOR on 114.1. 114.1. Actually, I'm going to set that one over here. 114.1. And I'm going to put Modesto 114.6 over here. And the reason I'm going to do that is because I'm going to be putting the ILS over here in a little bit. And I can lose Modesto first. 114.6. There we go. 1,000 to go. 1,000 to go. We still haven't crossed it, so we're okay. It's probably going to come in any moment. Here it comes. It's moving. Look at this. We're going to be like right on profile. So at the bottom of this, the ILS at final approach fix, we want to be at 2,700 feet. I'm going to go ahead and say, since we only have 617, we can't go below 65. So we're going to go 65 for the route. Right there. Boom. There's 10,000. Look at that. Perfect. And let's make sure we add some power because we're leveling off. Let's go 65. To do hundreds, we flip that switch down and go 65. And we're going to now go ahead and say, hold that. And bend that vertical speed on down. There goes the board right there. I'm going to go ahead and switch this over now to Modesto on this side, San Jose on this side. We're going to tune the next one, which is 227 at Bushy. Oops, not that far. 227, which is already starting to come in. And then the next point is going to be the 09 of San Jose. So this is going to be 09. Watching my speed. And we didn't do this at transition because we were a little sidetracked. So we're going to go ahead and open up the cooling doors all the way. So it's below 10,000 feet now. They are not fast to move. Alright, cooling doors are open. We're still holding 250 knots like a boss. Although I would like to be descending a little faster. Oh, we passed that point already. So this is the 09 at San Jose. We haven't passed that yet. At that point, at 09 at San Jose, that's when we go, we're going to actually, oh, this is going to be interesting because we need to, I kind of didn't do that right. Yeah, that's not good. All right. We'll go ahead and intercept it. We're just going to do waypoint 7 to 8, insert, and that would be 320. We're not far off. I'm going to put it on cross track. We're 25.6 to the right, and we're how far? Just going to kind of dead reckon this. We're 35 miles from that point. Okay. There's 65. I'm going to add some throttle. Landing lights on since we're below 10. I'll do the runway turnoffs on. Waiting for San Jose to come in. And in the meantime, let's go ahead and make sure we get the ILS. 108.7.296. 108.7. And that's locked up. So we're not picking it up yet, but we're ready for it. We're as low as we can go in this segment, and then we're just going to be very, very careful. We have a, like I said, we need to get down to 27. We have some terrain. Looks like the high point is around 2,100, so I think we stay above 4,000 feet, we're okay. So I think we'll go down to 4 next once we pass the San Jose point. .7 to the right. 32 miles. So we're closing the distance. I think roughly speaking from Sunol, we're doing about 259, 260, something like that. Which is when we cross here, that's Sunol. So we'll do 260 at that point. And we can know it's got to be at least somewhere over here because we know we're this side of the final approach course. So we got to get over to here. We got to cross this somehow anyway. So you can use your needles to kind of help you visualize yourself in three-dimensional space. Look at all those wind farms down there. This must be the Altamont. We're too... No, this can't be Altamont. We're too low. This is something else. Alright, we're just waiting for that San Jose marker to come in. Expect it will be sometime soon. See all the stuff that's sitting over the top over there. Here it comes. You can use the RMI to visualize when you think that will get it. When this RMI needle matches that angle, as it's slowly been swinging around because we're going past it, the VOR is sitting over here, and as we fly past it, it goes down here, and that needle tracks it. So you can kind of get a visual idea of, hey, I'm coming up on it. I'm coming up on it. You just have to look at the other end of the needle to understand where 09 is if you don't want to do the reciprocal. And you can use these RMIs really help you keep your position in space and understand where you are and where you need to go. All right, it is crossing right now, so we're going to start our turn. So we're going to go 260. I think that's probably about right. And we're going to go down to 4,000. I think that's a safe altitude for us. So we're going to arm altitude again. And once again, we're going to knock that V-speed down. Again, I've got V-speed control on my Bravo here, so if you don't have that mapped through SPAT or something, you'll have to kind of keep your head down and keep kind of one eye on that vertical speed indicator while you hit the vertical speed knob. And watch the speed. We'll pull that back a little bit. Now that concerns me right there. So I'm going to dodge a little bit over to the left more because I want to err on the side of coming up on this too soon. So I don't want to cut the final approach short. I'd rather go wide. And once we get past these mountains, we should pick up the localizer.
1,000 to go.
All right, 1,000 to go. Watching that speed. Again, checking over here. We're going to be landing, so we're going to put the other B pump on. So when we start extending flaps and slats, we've got everything. Everything else is fine. Fuel condition is good. We've got 3,000 in each tank, so we got 9,000 pounds on board. We're good. Getting a little fast there. Should be leveling us off. And we're going to go into the soup. This is where it gets fun. So it says 3,000, but it's really 4,000 because the thing is rolled back ever so slightly. Don't fall for that. I'm going to let the speed bleed off, so that way when we do catch this, we're not going too fast. And I don't want to go under 200 before we get the first notch of flaps and slats out, so I'm going to go ahead and put that first one out now. Because 200 is like our mid-maneuver. It's actually a little bit higher, or a little bit lower, because now we're lighter since we took off, but still want to not play with fire. Give it a little bit of gas here as we're losing speed and it's trying to hold our altitude. There we go. We picked up the localizer, so we got that now. And is that actually our glide slope, or is that... I'm going to keep my eye on that, see if it drops, because right now it looks like we're dead on, but I find that odd that it's not really moving either. Maybe it's going down? It's hard to say. I don't think so. I think it's... I mean, yeah, I think it is going down ever so slightly. I'm going to go ahead and knock this down to 35. I'll do a gentle descent here. I'm also going to shallow our approach a little bit here, so when we do intercept this, we're not like having to bank hard. When our speed has creeped quite a bit up. Look at that. Gotta keep an eye on that. Yeah, glide slope's going, so we're going to be under it. So yeah, we'll hold 35. That'll be good. Let that speed bleed down again. I'm really confused as to where this RMI needle is pointing right now. Because that's telling me the airport should be over here, but I don't think it is. But maybe it is. Maybe we're not as far over as we thought we were. I'm going to trust the... I'm going to play trust the RMI needle, because I think... We're doing this wrong. Because I'm still seeing myself in the hills, and we should not be in the hills at this point. So that tells me we cut the corner. So I'm going to actually run us back down the way. And we're going to get ourselves better established. This is why you're supposed to have radar vectors from Oakland. And I also did not think I should have programmed Sunol in here, because then I could have had the point from Sunol to our final approach fix mapped, and I did not do that, so that was my bad. So we're going to run back. And again, we're going to use this RMI to kind of keep an idea of where the airport is in relation to us. We're picking up the localizer. As long as we have that localizer, we have some situational awareness aside from actually being able to see the terrain, which is good in this case. If I could not see the terrain, then I would absolutely be bugging out of here. But as long as I can see the terrain, I can see clear of it. So, by the way, just so you know, I am not cheating. I do not have my airplane mapped on here. So I am not using this. We're trying to be true to form. So you see, I know stuff on here and mapping it, but my airplane is not here, so I have no idea. So I want this RMI needle to get somewhere close to that 30 marker. I think I'm going to go around this mountain and come back around like this. So let's do that. Let's dip and dip. Oh, and I let my speed go nuts. I'm gonna like over speeding the flaps. I don't want to go too far away either, because I will lose this at a certain point, and I don't want to do that. But I have some situational awareness of where I am, so I can follow some visual cues as need be. So let's start coming back around over here. Again, going this way will drive that needle toward our runway heading that we need it to be. And staying in the canyon here will keep us away from the terrain. So, pluses all around. I'm going to try to keep my speed right around 200 knots. A 90-degree angle is the sharpest way we can get that guy to move. And you can already see he's making his way toward 30, so we need to start booking it around here. We should be basically on an extended base leg now. And I'm watching that RMI needle like a hawk. That's 290 right there. We're going to start turning. little aggressive with the turn. Let's go ahead and level off. Don't cut it too short. We're aiming for the water. We know it's on the water, so much better situated this time. I'm going to go ahead and put flaps down to 5. Increase the speed a little bit. How are we doing on the fuel? Golden. 6,000 pounds. There it comes. Let's get it turning. We're going to go to Loc Auto GS for the glide slope. It's going to capture our localizer and then capture our glide slope. Money. That would have been a long way to crash in the mountains near outside of Oakland, so I'm glad we figured that one out. The dead reckoning didn't work very well. We lost situational awareness, but we were cognizant enough to find it again. And that's what matters. Alright, there goes the glide slope I just captured. So pull the power back a little bit more. We're about 14 statute miles, which means we're probably about 12 nautical miles from the field. And I think I just got the runway right there. Alright, last check over here before we go full front focus. Cooling doors are all open, all the hydraulics are ready to go. Everything looks good. Yep. Fuel situation is critical, but we're not in danger at this point. We just don't want to go around. Alright, let's go ahead and drop the gear. And flaps 15. Alright, gears down, 3 green. Keep bringing the power back a little bit. Aiming right around that 3,000 pounds per engine. It's a nice even number there. Go flaps 20. Below 160, we'll go flaps 30. Alright, flaps are 30, green light, gears down, 3 green, landing clearance received, we get into ourselves, taxi light goes on. We don't have speed brakes to arm, we're not using auto brakes. We have to hit the speed brake ourselves, and we'll have to brake ourselves, so. We'll have use of full reverse. Runway's in sight. Just a little above 1,000 to go, and we'll disconnect the autopilot. There's 1,000. We'll pull the power back a little bit more, right around. I want to hold right around that 3,000. That's kind of a sweet spot for this thing. Okay. Autopilot's out. It's my airplane. No autopilot, no auto throttle. It's all me. is a little bit crosswind gusty, if you recall from the weather report, so we gotta be careful here.
500.
There's that crosswind.
400.
A little bit of rudder trying to...
$300. 200. 100. 50. 40. 30. 20. 10.
Ooh, nice. Nice and firm. Go into reverse. Spoilers out. Full reverse. Knots, idle reverse, reversers out. 259, not too shabby for a big old crosswind. I'll take it. Switch over to the tiller. Spoilers up. Flaps coming up. Landing lights off. Strobe off. Welcome to Oakland. Not too shabby. All radio navigation, no magenta line, Florida to California. It can be done. It's a lot of fun. All right, we're going to come into the back here, and we're going to flip that ground flight switch to ground. And we want to get the APU going as well, so let's go ahead and flip that up. Get that running. Cooling doors are already open, so we don't have to worry about anything there. The flaps are coming up. The spoilers have been retracted. Getting evening, I'll put the logo light on, why not? Pull the airport chart up here and see what this is. This is Victor. We'll go to Bravo. We'll go to the next one. So we have to turn on to that anyway. We're going to Fox 16 on the FedEx ramp. So as soon as we turn the straightaway here, I'll see if I can pull that up with GSX. Alright, let's see if we can get GSX to tell us where Fox... I mean, I know where it is, but... Fox 16, I said? Yes. 16, ramp cargo. Nope. Should be FedEx. Excellent. Alright, we'll flip this all the way to 0 for the next crew. And switch that back to thousands. Put the gear warning back in. The gear warning will just blare at you if you close the throttles without having the gear down. And since you're when you're trying to lose speed in this, it just gets annoying. So it's something you can pull to make sure that doesn't happen. The downside, of course, is if you close the throttles and forget the gear's not. I mean. You should know whether or not you're on a landing roll, I guess, but it can be a last thing before the stick shaker goes, before you know that you're about to fall out of the sky, I suppose. We can go ahead and turn the window heats off now. Part of the shutdown is going to be, before we switch over to the APU gen, is relieving some of the electrical load, and that includes pulling off some of the pumps and things. So we're going to come back here. I'm going to slow this down. We're going to put back to 1 pump each for that. And And we're going to turn one of the B pumps off again, since we're just taxiing. I think it's the... No, it is this one, yeah. We got to go up and around. It's on the other side of this building. We got to go up and around. You'll notice I really didn't use the flight director at all, and that's because, for me, this thing just makes it harder to see the lines, and it's not that helpful. The pitch axis is almost unusable because it's not tied into anything, and generally speaking, I can look at the VOR needle and see where the roll needs to be. It could be helpful if you're using it with the INS, like to fly the INS without actually having the INS coupled, but otherwise, I just find it's simpler just to keep it off, so. So here's our stairs, there's our guy, our director buddy. As we come in here, we're going to turn off the taxi and runway turn-off lights. Slow this sucker down quite a bit. Get some of that good old 727 JT8D sound love. Hey, stop that crappy lag spiking. These GSX profiles have this marshaller way too close to me, so I'm going to have to do that to see her. Oh, we were still moving. Stop moving. Come on. See what I mean? I need to edit this. Alright, there we go. Brakes. Parking brake set. We've already basically made sure the AP is good to go. We're going to cut it over. And then we're going to switch this to APU standby power. And we're going to open the APU bleed so we have APU air. And we're going to cut the engines. Tell GSX to bring the stairs. I said operate the stairs. And we're going to turn the seatbelt sign off. I'm going to open up the other, get some air here in Oakland. Got Oakland air. And we want to make sure the beacon's off as the engines are off now. So it's just nav and logo light. We can come out here and open the door. We'll get the cargo bay opening while the stairs are coming up. You can see our stairs out there. They will actually, GSX should open the door as soon as the stairs are connected. So. There they go. There's our stairs. You can see our door is finishing opening right there. And at this point, we can go ahead and turn off the remaining fuel pumps. Set these back open, the bleeds. And turn on the various lights for the next crew. Whoever's coming in next, dome lights and what have you. And we'll just leave this all up. If you wanted to shut all this down, obviously I would turn off the packs. The APU should spool down, should be packless for about a minute, 2 minutes. And then once you do that, then you can shut the APU down. You go back on battery or ground power at that point. Make sure to switch the essential power to the external if you go to ground power. Turn off your galleys. Make sure your other B pump is off at that point. All the other lights can come off. Oh, we didn't hit the pitos off. That's the other thing we missed. But we got that. And yeah, that's it. You can also come up here and turn the INS off. Switch that guy off. I'm not going to go ahead and shut the whole thing down because I'm going to assume that some other crew is going to come take us. It's FedEx. They got things to do. But there we go. We have landed in Oakland. That is the... Oh, man. I haven't done a long flight like that, transcon, in a long time. But it was actually really fun to do it with this airplane. It did not feel like it took 5 hours, even though that's what it took. But it didn't feel like it because you're constantly working the aircraft. There's constantly stuff to monitor and do. It's not like a 737 or 777 where it's set it and forget it. So I encourage you guys, if you've never attempted to fly this way, try it. It's a lot of fun. And this aircraft, like you saw, it has a number of bugs. They're working on it. They're going to get those squashed. It's totally flyable right now. It's totally fun to fly right now. But it's going to get even better in the coming weeks. So keep an eye out for that. Flight Sim Studios 727-200. Go check it out. Go pick up a copy. I think it's like 42, 45 bucks US, something like that, I want to say. And I think right now it's only available at the Aerosoft store, but eventually it will be available through like Sim Market and Contrail. And rumor has it you can buy it through Aerosoft, but you don't have to use the Aerosoft downloader. You can then go and plug the numbers into Contrail and download it through Contrail even though you bought it in Aerosoft. So, and I've heard some people feel like that maybe the Aerosoft version was giving them problems for some reason. I don't know. Mine came from Contrail because I got a press copy. And so I don't know. But there you go. Possible life hack if you want to get it out of... So I know a lot of people don't like the Aerosoft One downloader. I haven't had any problems with it personally, but I know people that don't like it. So, all right, that's where we're going to end it here. I love this aircraft. I'm having so much fun with this aircraft. So big thank you to Flight Sim Studios for hooking me up. And I'm not just saying good things about them because they gave me the plane. I literally am very impressed. Even with the foibles, even with the blemishes that it has at the moment, they're going to work on. This thing is so much fun. So much fun. I think I found my new favorite slant whiskey aircraft. This just blew the Fokker out of the water. So, all right, that's going to do it for me. Look for my masterclass series on this. Once we get through an update or two and we see that the systems are really banging on all cylinders, then we'll do the multi-video masterclass just like we did with the Mad Dog, and similar style to the MD-11. Take care, guys. Thank you so much. I'll see you over on Twitch. Peace.